Good morning. Good morning and welcome. If you have any friends lingering out in the hallway, you can ask them to come in now. So I'm Sonia, and I am the Associate Director for Dataverse Support and Data Curation with the Dataverse Project. It's a real pleasure to meet all of you today and have you come, pretty far to take part in CIMMYT's regional community meeting. As most of you know, a couple of years back, we started talking about holding regional meetings so that we can facilitate discussion and community with our groups outside of the United States, because it was really important. We have large groups outside the United States that we wanted to ensure would be a part of the annual community meetings and would take the opportunity to host and have a focus on their community needs, as well as talk about the general Dataverse project and all of the features and tools and discussions on ongoing collaborations that we are building together. So this actual meeting with the CIMMYT community has been in the making for about 5 years. COVID interrupted a lot of things, but we were trying to get it done. So I want to say thank you to Richard and Jesus and the CIMMYT team here for allowing this to happen and staying with us through the pandemic to ensure that we could get together today. So I'm going to give you a brief overview of the day, and then we are going to start the agenda for the plenary, which is going to be an exciting full day of updates and presentations and discussions. So today, we are going to have a welcome by Dr. Bram Hoverts. We're going to have Dataverse updates, brief community survey updates that were done by Harvard Dataverse. We're going to have an update on tools and features. We're going to have a new session this year that has never happened before. We asked Phil to talk about the community and give us a really good overview of what is happening in the community, because Phil is our community guru. Everybody knows Phil. So he's going to add that, and that's going to be a standard, a staple in all of our community meetings going forward. And of course, we're going to have the GDCC updates. In the afternoon today, please keep in mind that there's a CIMMYT tour that you can sign up for. We just need to know how many people are going, because it's limited to 30 people per day, of the Germoplasm Bank and the museum, which I tell you, please visit the museum. We're going to have a keynote by Dr. Halud O'Day on the future of open data in the era of AI and generative AI. And we're going to have a talk on Dataverse and National Research Commons, a talk on a data station for the life sciences, reaching out to the Dutch life science community with a Dataverse-based repository service. And we're going to have a talk on the internationalization of Borealis, the Canadian Dataverse repository, which hosts over 71 organizations in their community on one Dataverse installation. And at the end of the day, we are going to have a talk on World Fair, CDIF, and cross-domain fair resources, Dataverse as a fairer repository. And we're going to have, at the end of that morning session, a Q&A panel. So this is different from what we've done in previous years. We're going to have these closely related topics and then a panel where you can ask questions and we can have some discussion. And we are going to end the day with a talk on large data support and Globus and Dataverse, integrating research software in support of fair data, followed by a Q&A. So welcome to an amazing day. I'd like to introduce our new director, Stefano Iakis, who is going to introduce our Dr. Bram Hovert, who is going to do our welcome.
So thank you, Sonia. And thank you, everyone, for being here. And also to CIMMYT, especially to CIMMYT for organizing and making this possible after all it happened with COVID and so much expectation around this conference. So I'm here to introduce the Director General of CIMMYT, Bram Hovert. And because his CV is impressive, it's really impressive, I put some note here that I have to read to make it through it. So Bram is a renowned pioneer for pioneering, implementing, and inspiring transformational challenges for farmers and consumers in meeting the sustainable development challenges. When He approached any of these. He brings together a multidisciplinary science and development teams to integrate sustainable, multi-stakeholder and sector strategies that generate innovation and change in agri-food systems. So his work is geared toward transforming subsistence agriculture and failed farming systems into productive and sustainable production units. Ethiopia, India, Mexico are concrete examples of his valuable work. So Howard's developed a vision inspired by the Norman Borlaug motto, take it to the farmer, which means combining the right seed with the right conservation agriculture production practice embedded in an integrated market while recognizing and integrating farmer knowledge. So I've been working on these kind of things from the statistical point of view as a statistician. And this is a very important aspect of development. So I'm really thankful for your vision. So Howard studied at the Catholic University in Leuven, Belgium, where he obtained a bachelor degree in bioscience engineering, then a master's degree in soil conservation and tropical agriculture, and a PhD in bioscience engineering and soil science. Gover's work has been awarded and recognized through many prizes. In 2003, he received the Development Cooperation Prize from the Belgian federal government. In 2014, the Norman Borlaug Award for Field Research and Application by the Rockefeller Foundation and the World Food Prize. In 2019, he received the Premio Tecnoagro, awarded by the organization of 2,500 Mexican farmers. So he is a member of Sustainable Development Solution Network and the A.D. White Professor at Large at Cornell University. And in 2020, he was elected as Fellow by the American Society of Agronomy for his outstanding contribution to the field of agronomy. So please welcome Bram, and thank you again for having this meeting here.
So, thank you very much for that very generous introduction. And I have to confess that I'm a bit jealous of all of you, because you will be able to stay here and listen to very exciting presentations the rest of the day. Unfortunately, I will have to run away because as a Director General on my agenda today, I have a very interesting audit meeting. So you just see how life can change from very interesting systems work to some other duties. But good morning and welcome everyone. Today is a big day for CIMMYT. This is the 2024 Dataverse Community Meeting, of which you are all part. And I want to recognize first and foremost the work you as a community have been doing and the importance of data systems and how you as a trailblazer have been moving this forward. Therefore, of course, I want to thank Harvard University. I will forgive that it's not Cornell. No, that's a joke. So I want to thank the Harvard University, of course, for your efforts. And I can be not more excited and proud of having this meeting here at CIMMYT. This is the second, if I'm well informed, Dataverse community meeting that takes place outside of Harvard University. And it is this time in the midst of what is a nerve center for global stability. Maybe not everybody of you knows what CIMMYT does. And I hope this afternoon you have the chance to look at one, to go and visit one of the buildings right here, straight forward. That building safeguards for humanity the biodiversity of maize and wheat. It is proof to impacts we have, that's what we've been told, I don't know, we have never tried, but of an airplane crashing on the bank, in order to protect especially the second part of the bank, which is below ground, which you will not be able to visit. Only a few people can visit that one, but you will be able to visit the active copy that is on the top, which has 28,000 maize accessions and 150,000 different wheat accessions. And so from that maize and wheat, we develop One of the things CIMMYT does is to develop new wheat varieties globally. You may have heard that in '99 we identified UG99, which was a new rust disease. Unfortunately, global wheat was not resistant to UG99. So that was COVID for wheat, right? We didn't know which varieties were resistant. We did know that a huge amount of wheat varieties were not resistant. Luckily, to a great effort, we identified within the gene bank, and this is where you come into play, those varieties that are resistant and could integrate them into CIMMYT's elite background and spread it rapidly throughout the world to replace those varieties. And so most of you, I think, have never heard from a UG99 crisis. And it was because there was no UG99 crisis, because we could prevent it by sending out and replacing the varieties globally of wheat and make it resistant to the disease. But as you know, with COVID, we had COVID 1, 2, 3, and then we gave other letters and other things. Same thing happens with UG19, with rust. Today we have a blast crisis, potentially. Blast is spreading rapidly through the world, and so Latin American germplasm is not resistant, so what is out there in the world is not resistant to blast. Those that follow the news may have seen that Zambia has a record high El Nino impact with severe drought. We are preventing deeper impacts. 7.5 million hectares in Africa is now planted with drought-tolerant maize. And I hope in your visit you can see some of the difference between non-drought-tolerant and drought-tolerant. We have characterized those 28,000 different maize entries and the 150,000 different wheat entries, and that became a gigantic database, and that's when we got lost. So that is where we have you here now today to help us navigate more and more the vast data that we have. Since CIMMYT sent out wheat throughout the world, which was started 80 years ago, and let this be the welcome for 10 and 11, 10 and 11 of July, we will be celebrating 80 years of Norman Borlaug's arrival to Mexico. And Norman Borlaug received the Nobel Peace Prize for that, and he saved 1 billion lives, or is accredited with having saved 1 billion lives through maize and wheat varieties. Today, 70% of the wheat globally comes from the research here. 50% of the corn includes CIMMYT's research. So if you this morning had a piece of bread, if you this morning had a tortilla, I hope you had tortillas, you're in Mexico. If not, please have a tortilla tomorrow. Very likely you were eating CIMMYT's research. That is the impact. We send yearly 500,000 seed packs globally. And since 80 years ago, we get the data back from multiple collaborators in multiple sites globally. So imagine the database that is sitting there since 80 years ago, different varieties sent all over the world, different ecosystems, tested, data come back, and that's what drives our next decision. So one wonders why was this community not here before? We have been collaborating with you since 2014, actually. And so our colleagues from the Data Management Unit and Knowledge Management Information Technologies Unit have been working hard with you as friends to really bring this event here together. Together, we will also want to upgrade and improve Dataverse as one of our most important platforms globally for storing and openly sharing data with the scientific community. I want to recognize that this meeting would not have been possible, as always, without the colleagues of the IQSS, and I want to sincerely thank you for that. But also, I want to have a shout out to the CGIAR as the broader community, and I think Kulut is here as a representative. And I can tell you she's one of the smartest global directors of the CGIAR that we have. So we could not have a better representation here than Kulut today. I, of course, want also to thank for our generous sponsors, Open Research Funders Group, Hewlett-Packard Enterprise, Bayer, and DataCite. And I hope you as representatives can bring back to your company that you have not only been working on data, but that in these 2 days you have been helping to feed the world. I really want to encourage you to not forget that those that we finally serve are the farmers globally. And it's for that reason, and given the current crisis, that CIMMYT has launched a new 2030 strategy. The 2030 strategy wants to accelerate and double our footprint over the coming years. In that strategy, I have identified 3 pillars, and in all 3 of them, we need you and we need your help. Number 1 is discovery, our varieties, our agronomy, our machines. Second, we call system dev, big systems interventions, working with 500,000 farmers. You will get a presentation tomorrow at 9:30 by Seek Snap, who will show you some of that data-sourced data from farmers in that system dev pillar. Last but not least, we have a CIMMYT Inc. pillar, which is a bit new, which is looking at how can we work with startups. Several of you represent startups here. How can we work with different business models? And so we hope that also collaborations can develop there. In our strategy, we have 6 components, the most important one being the excellence in science and innovation. But excellence in science and innovation cannot be achieved without excellence in operation, resource mobilization, talent management, partnership, and of course, influence. We have 5 strategic objectives, and I want to walk you through each of them. Our first objective is, how can CIMMYT be a better partner? So under that first strategic objective, I want to make a deal with each and every one of you. While you are here, what you see that works well, please congratulate the team. They're working day and night to make a difference. What doesn't work well is for sure because I made a wrong decision, so please send me an email and let me know. That way, we can become a better partner for all of you. Second strategic objective is, how can we generate our innovations, our seeds, our agronomy, our machinery in a better way so it fits better the purpose. Our third strategic objective is to generate livelihood trajectories with farmers and her family. Why do I stress livelihood trajectories? It is not about giving enough calories today to that family. It is not about a healthy diet today. It is not about income today. It is about generating the livelihood components that can give the family a trajectory. It is not the same to be a family today with 2 little kids than tomorrow having to send them to university. So whatever we do needs to underpin a trajectory of a whole family to have a healthy life. Our fourth strategic objective are our boundary conditions. Even if we have the best innovations underpinned with the best livelihood trajectories, if that goes at cost of the sustainability and the resilience of the agri-food systems, we will not accept those solutions and will have to look harder. Our last strategic objective is to actually become better at transforming our data and information for decision-making and the decision-making for decision-taking. I don't have to explain you that data is one thing, information is something very different. Information towards decision-making is the next step. And it's not because you made the decision that you have the luxury to actually take the decision or action on the decision. So in our fifth strategic objective, we want your help to become better at transforming our data and information in the right decision tools at different scales. Be it for farmers, her decision to put or not fertilizer, to change a variety, to change a market, the community level, the country level, the regional level, and why not? How can we provide better data and information for decision making at a global level? UN General Assembly, Security Council, for sure. There is a need, definitely, to take some better decisions at global level. And you can make that happen if you allow the information and the data to be part of those decision tools. Therefore, CIMMYT, yes, is the Maize and Wheat Improvement Center, and you will see that very nicely in the logo at the front of our name. So we are about corn, maize, and wheat, but we're also about much more. We work on different other crops like groundnuts, chickpeas. If we want nutrition and resilience, we need diversified systems that are also way more complex. We need system thinking. So we added a swirl at the end of our logo to recognize our legacy, but to also project us forward. And that swirl you can see has different colors. So it's the different crops that need to go into the maize and wheat cropping systems. Monoculture will not do it. It also has three colors. It is crops, it is soil, it is water. So it is the soil, it's the plant, water, soil continue. It's also the nexus between energy, water, and food. It also represents the diversity that we have in the organization. We are over 50 nationalities working in 80 countries with headquarters in Mexico, but offices in 15 countries, and impact in those 80 countries. We come from diverse backgrounds and diverse cultures. So we believe everybody has a chroma, a different color. And it's by bringing those colors together that we really can make a difference. Therefore, I'm very proud that you will hear from one of our trailblazers on diversity and diversity in development, Seek, and Seek is going to be very busy because on Friday, she's actually also going to launch our new hub for gender in development in honor of Paula Cantor. And those that know Paula Cantor know that she, unfortunately, was killed by a terrorist attack in function while she worked in Afghanistan on gender issues. So if you happen to still be here on Friday, join us for the launch for that very important moment. But Seek will, for you, present data and our operations on a monitoring system that has now been running for more than 10 years, that has been working with 100 partners in Mexico, Colombia, Honduras, Guatemala, Peru, and India. And so through the strategy, by the end of 2023, we had 127,000 farmers registering 298,000 plots, monitoring, and with that, we can, of course, imagine that those huge databases can be used for decision making and taking. I don't want to tell more, but because then I would steal Seek's presentation. So let me, for a moment, pivot to Kulut. Kulut will also give us a very interesting presentation. And I'm definitely going to make sure that I can see the videotaping of that one, because it's about the future of open data and the era of AI and generation of AI, and it will be later today at 1:30. I saw many of you also as distinguished speakers and a series of engaging presentations. So for those of you that it is the first time visiting CIMMYT, please do visit the germplasm of the world for maize and wheat. In the end, it is two of the three crops that feeds us daily: rice, maize, wheat. It's not every day that you can realize, for those that come from the US and from Europe, as myself, that no, corn is not just yellow and white. It's also blue, red, purple. Actually, the majority of the corn is not yellow and white. So imagine that you can help us by not only using 5% of global biodiversity, but use the other 95% that we haven't used yet. And let we have a big task to feed the world in the future. Let we have a big task to transform our agri-food systems and make them more resilient. We have kind of run out of the efficiency paradigm. We're going to have to look at resilience. How much redundance can we allow within the systems? How much coming back power sits in our systems? And we need to pivot the food systems. But the bad news is you cannot just switch one system off and switch another one on. We need smart people like you to design the trajectories, to extract the information that is there, and to allow us to further and more effectively design systems that in the middle have the agronomy that does the right thing with the seed that is no longer only using 5% of biodiversity, but the other 95%. To be more nutritious, to be more resilient. So if you hadn't understood, we are standing on the shoulders of giants. In the morning, if you pass Norman Borlaug, if he smiles to you, you're in good shape. If he looks a bit grumbled, don't be surprised, it's happened regularly. It's out of frustration of the current situation in the world. It's out of frustration because some are trying to do the same as he did in the past. And that's not gonna work. We need to do better, we need to do different, we need to do and be more generous and take a systems approach that really includes all the capabilities and opportunities that we have at global level. So if you hadn't understood yet, by signing up to this meeting, there were very small letters on the bottom. You will not be able to say, 5 years from now, I didn't know there was a need for my talent to change the world and to make sure that we can feed it. Thank you very much.
Okay, this one? All right, everyone. And before I go any further, yes, let me thank you, Dr. Bram. That was a very inspiring introduction, and it's really nice to be in a community where you can see the value of the work that you do and how it impacts people. So let's not forget, it's the 10th annual meeting of the Dataverse Community Meeting. And I think all of us kind of forgot it was the 10th year as well when we were planning this meeting, but it's the 10th annual meeting. So make sure you tweet hashtag capital D Dataverse 2024. Hashtag capital D. I have two things open. I have a phone open, I have a laptop open because I'm tweeting from 2 different accounts. So help a sister out. Thank you. So I'm going to introduce Stefano IQSS, the Director of Data Science and Product Research at IQSS, who is going to be giving Dataverse updates today. Oh, I touched it, I messed it up. Okay. Dr. IQSS is the Director of Data Science and Product Research at IQSS. He's also the Managing Director of the Dataverse Project and a member of the Executive Committee of the OpenDP Project. Stefano started his academic career at the University of Milan, where he became full professor of statistics in 2015. Between 2019 and 2022, he served as officer at the Joint Research Center of the European Commission, where he led the team that explored the usage of non-traditional data sources in the context of evidence-based policy making in migration and demography to support action during crisis periods and to refine preparedness measures. He has a recurring visiting position at the Graduate School of Mathematics at the University of Tokyo, Japan, where he co-leads the UIMA project. He's been a member of the R core team for the development of the R statistical environment until 2014, and is now a member of the R Foundation for Statistical Computing. During the COVID pandemic, he managed a large-scale business-to-government project for the European Commission, producing insights for policymaking using data from mobile network operators covering most European Union member states. So we welcome our new boss, as I like to call him, Dr. IQSS.
Thank you, Sonia. Oops, I messed up. Okay. So thank you again for making this meeting possible. It's the 10th year of this meeting, and it's my second meeting. Last year, when I presented the similar talk, I promised a few things. And now I will update you about the status of these promises, and you can judge whether we made a good job or not. First of all, let me say that there are 8 people here from IQSS, plus some external contributors like Jim. But there are others which have been staying home, keeping the machine working for you, for the community. So let's not forget about the complete team members. So yeah, I start from the end. What an amazing year for Dataverse has been this last year. And by the way, It was not even an entire year, it's just 9 months, because the last meeting was in June last year, and now we anticipate it in March. So 9 months, like growing a baby, and it's much more than a baby. So let me go through these numbers. You know most of these numbers because these are on the Dataverse project, but let me go through it. First of all, so what's in Dataverse as a network of dataverses, let's say. So first of all, you know that it started as a social science repository, and then it transformed into something else because it's a generalist repository, so it's not field specific. Then if you look at the numbers, 500,000 datasets, exist in the Dataverse network, almost 6 million files. You know that each dataset is more than just tabular data, it's a lot of information that comes with it. Storage, of course, we know only the number for Harvard Dataverse. Now Harvard Dataverse includes 70 terabytes, but in the next 2 weeks, this number will grow by 10 because of the innovation that we recently made. So 70K users, of course, not at all active, but they contributed somehow to the Harvard Dataverse. And I guess on your installation, these numbers are equivalent. Okay, it's a lot of data, but so far it's still say small to not so large data, which can be hosted in Harvard Data. Not because of Dataverse, but because Dataverse is there since 2004, and this was the scale of the data so far. So what's new in terms of growth of Dataverse? So last year we had 14 new installations, so in 2023, and then a couple of ones are being added just in January. It's a real growth, as you see, it's a steady growth, and probably with containerization, okay, the containerization potentially, which will probably, we will probably go much farther than this, say, nonlinear growth. Then there are 3 new members which have been added to the Dataverse core team at IQSS last year. So Juan Pablo, Stephen, and Matthew. And you see now there is a dedicated front-end person in the team, apart from Helen, which is both front-end and back-end. We have a new grant which kicked in last summer, actually last May, and it's called Cafe U24. Why I'm mentioning this here? Because this is still another field of research. So this Cafe grant is about creating a metadata system for environmental and health data. So it's a huge set of data which is coming into Dataverse, and this field has no very well set system of metadata standards and so forth. So we are helping them, and we are also, from the curation point of view, thanks to Sonia's team, but also from the development point of view. Then we just yesterday, before I came here, we have been awarded by the 3rd year of the grant NIH, which is this competition between among several generalist repositories, which Dataverse is one of the participants. And so this is very important because we are implementing a lot of the stuff that you are going to see during this conference. And then we recently received a small grant about foundation models, so AI, from Microsoft, with which we will boost a bit some of our work on the AI side for Dataverse. So this is about the growth. And now a bit of technical innovation that has been done during 2022. The first one is the real support for large data. So we already have some way to host large data through, say, Globus transfer, but now this, with version 6.1, we fully implemented the Globus transfer, which was very important to support very large data, especially because when you interact, these large data are usually on tape, on this scale, and when you interact with this data, it's very hard to do with this, say, in an online system. So with global support, we have direct access to the API, and we can better manage the user experience connected to this data. So there are at least 2 talks that I suggest you to attend. One is by Kaylin, and it's about how to also build services around this large data, and what we are doing at Harvard Dataverse, and also the technological partner. And of course, there is the Globus talk by Jim, just after that talk, which is about the actual implementation of it. Then the other thing that we finished last week, we presented February 28 at the Mass Open Cloud Alliance workshop. So we prepare, say, a proof of concept, so a separate installation. We are not yet in production, but the whole workflow is now implemented. So the idea is that you can upload through Globus data on tape or on disk, and if there is some, if this deployment is done on infrastructure where you also have the computing capability, and you have, for example, a Python notebook there, then there is a new item in this top-down menu, which allows you to compute on data, which means that you click that button and you're sent to a Jupyter notebook, and then you do calculation. Why this is important? Because we are going to this scale of data. So gigabyte or terabyte is now the usual data that we have. And now in the present version of Dataverse, even if you have terabytes of data, Dataverse, you have to download the data and explore them locally. With this system, you are not moving data. So what you're doing here, you're just sending to the memory of your Python, say, notebook or R notebook, your data, without moving data across the internet. And you, of course, you save money and you save time. And then, if you like the data, you can download them. So there will be a presentation with me and Kaylin later. Now, the other promise I made last year, we wanted to separate the backend and the front end. So it was a big effort. It is still a big effort, which is about separating the backend and front end. This is the present front end that you all know, of course, of Dataverse, and this is the beta version of the SPA, which is not complete. Ellen will talk exhaustively in one talk and one entire workshop, which I suggest you to attend. Because essentially we realized this idea of having a separate front-end and back-end, which allows much more interoperability within the library systems, and also more flexible and and hopefully faster UI development. And by the way, by this new SPA, you have many things that come with it. So you have internationalization, you have accessibility, and so forth. All of these by using the latest standard. But because we separated front-end and back-end, now we can fully control Dataverse through API. So for example, you know the project PI Dataverse, which we will have a dedicated working group during this conference. We'll introduce you to the concept of using open API layer, let's say, between Dataverse and any other language. So PyDataverse is just the first example, but it can be JavaScript, it can be R, whatever, so that you can control with a standard API set of APIs, fully operationally Dataverse. Then another big achievement by the community and led by Phil is the containerization of Dataverse. Now you can spin a container with Dataverse on it. You are up and running in a few moments, let's say. We are extending this capability. I mean, there is a reason why the working group is still working on it, but it's already there. So, for example, for the MOC Alliance, we just spin a container on their infrastructure, and all the work was done in a very small time. Of course, this will simplify the adoption of the system. It will probably multiply the instances. There was a discussion today at breakfast about multiplication of instances even within the same institution for different purposes of Dataverse. Then AI. So we have done some work around AI. We already released the Ask the Data chatbot, which is a toy chatbot with which whenever you see tabular data in Dataverse, you see this kind of icon appearing, you click on it and you can start asking questions to your tabular data. It's a silly thing, but it's just the beginning of what we're doing is a proof of concept. But we are also experimenting with semantic search, and many others, of course, are doing similar things. So I suggest you, of course, to see my talk, just to see in practice what we do at Harvard Dataverse. And then there are a couple of talks by Slava and 2 keynotes about AI. So it's really at the moment, and Dataverse is in the loop. The other thing we did is to go one level down in terms of metadata. So we spend a lot of time saying that we have metadata fields and so forth, which allow to, because we are a generalist repository, which allows you to essentially include data from any type of field of science. But if you go one level down, so if you go to the, suppose you have, let's say, a tabular data, you go to a column and you want to see what's in this column. Oh, it's gender, and it's in my data set. How many other data sets have gender as a column? Can I link them together? And is it about US, is it about, I don't know, any other place, and which time of the year, and so forth. So essentially, if we go one level down, and this is something we are pushing for this year in year 3 of the NH grant, so to work more on file-level metadata, so that we can do what we already start doing. So what you see here is the version, the Dataverse version, let's say, of the Google Data Commons project, which is about putting together different type of data sources linked at variable level. And so what we did, we add Dataverse data. So we started with like a few hundreds data just to test the concept. And what you see here is the scatter plot between data from New York Times and data from one possible Harvard data sets. And this is done automatically once we expose the file-level metadata to this engine. So now we are temporarily using Google Data Commons to do the joining of the data, but we are preparing the infrastructure so that in future, we can actually do this within Dataverse very easily. So what we are also doing, this is not final, but it's just my attempt to extract from my mind what I want to see for Dataverse in the near future. So we're trying to see Dataverse not just here as the place where you share data, but along the whole research life cycle of your data. And not only for research data, also for administrative data. So administration produce data endogenously. This data usually, if you're lucky, they go into some Excel file or they go into some data lake. But once the data are in the data lake, you don't know what's in the data lake unless you put the data. So the idea is that why don't we create a layer, which is Dataverse, which is interface between the data lake and the user who want to discover the data, the administrative data. So this is still a black hole, even in many institutions, all the institutions I know. It's very hard to get this. And by the richness of metadata structure and interoperability of Dataverse, this is how I see everything. We already have the integration with the working paper repository through Dash. We have the computation, which I showed you before. We're trying to integrate with secure storage data and to the persistent storage system at Harvard. And this is related to the sustainability of Dataverse, so the future of Dataverse as a project. So my vision here is for Harvard Dataverse, but I would like to make the software able to do all of this for any institution. So it will become a Dataverse project, say, vision. So there are 2 important meetings which are happening now and 2 working groups. Of course, there are the GDCC updates that Philip will present, but there is also the sustainability working group, which was launched last year, and which is trying to understand possible models about the future of Dataverse. So Dataverse is a strange project. It's an open source project, but the money from the project comes from Harvard. And the community push for having more and more features or particularization of the software and so forth. How to manage this? So the sustainability working group is working on this. So let me thank, this is a slide I must have. So of course my team, I call it my team, but it's the Dataverse core team, DCC, which has done a lot of work by being the interface between all the installation and our team. Our contractor, Giant Monkeys, they did a great job in helping us with the acceleration of the SPI development. The curation team led by Sonia, all the contributors from the community, plenty of examples at the conference, and also our stakeholders and founders, without which we will not have a Dataverse core team. So challenges are not over, sustainability is one, new ideas just keep coming in every day by everyone. Do not miss Gustavo's talk, which will give you a deep dive in some of the new features and details around Dataverse. Yeah, that's it. I think I can move to the next one. So just before coming here, I decided to send out a mass survey with very few questions, just about Harvard Dataverse. So this is not about the community meeting survey, which will be discussed in other sessions. So I asked for 5 simple questions. What do you like about Dataverse? What you don't like about Dataverse? What you would like to have implemented in the next year? Would you recommend its use to your colleague in other fields of disciplines and so forth? And which type of user are you? By type of user, I mean, are you a librarian? Are you a researcher putting data on Dataverse? Are you a journal editor, whatever? So we collected the data from February 15 to March 1st, just before I took the plane, and we got 1,700 answers. It's a preliminary analysis just because I did the analysis on the plane. But it's already interesting what we see in the data. So first of all, you see the distribution of people who actually answered the questionnaire. So this is self-selection on answer. So most of them are researchers depositing data. And they reply to our survey, meaning that they just didn't deposit data and then they went somewhere else. They are some kind of fidelized with Dataverse because they took the time to answer my questionnaire. Researchers mostly looking for data, it's a big part of them, and then librarians. And there are also 7 devs, because we cannot identify those, but I can imagine who some of them are. Anyway, so this is the distribution of the people who respond. So you have to, when you read the answer to the question, what you like, what you don't like, you have to keep in mind who is the target audience for this survey. So I did this simple Net Promoter Score analysis, which is something it's very common in the marketing environment, let's say. So when you have this question, how likely would you recommend the use of this repository? You have a scale from 0 to 10, and then you define the factors, those who score you 0 to 6, promoters 9 to 10, and 7 to 8 are passives. And then the Net Promoter Score is just the difference of these 2 numbers. Can you guess the number for Dataverse? Slava. What do you think is this number? 100%, no. I call the people I know. Dimitri, tell me a number. Any number. What? 30. Ah, she cheated. So the number is 34. Is it bad or good? So let me say, I am a statistician. Net Promoter Score is not science. it's something from the marketing side. So let's see if it is good or bad. So this score can go to 100 if everyone is happy, no one is unhappy, and minus 100. So we are above the threshold, 0. So let's see how this score usually looks into different sectors. So there has been done several analyses. One that I pick at random says that, for example, for technology companies, usually their products are rated 35%. So the typical net promoter score is 35%, which is kind of in line of what we have here. United States is 36% across every product, every industry. Japan is minus 47, they are never satisfied. Brazil, they are very happy. India are very happy. So what's the good value of NPS? There is no good value. That's the point. The point is that, okay, once you have a value, next year, or probably possibly in 2 years, I will do the same and I see whether this number decreases or increases. That will be an indicator that we are doing good or bad in trying to understand the consumer side, let's say, the user side of it. And so, after all, I can say that NPS is not so bad as a 34%. Also because if you look at the real distribution here, 54% of the respondents are very happy about the product. So that's why I'm saying that NPS is not science. It's just a definition of an indicator. What I see is that there is no difference in the user type. So essentially, promoters and detractors distribute evenly across the different, say, positive, negative. And then the critics, some of the critics are already being addressed. Let me show what these are. So among the critics are the user friendliness and GUI, but we are working on it. We have the SPA. So we're trying to get there. There is also a UX research working group led by Julian, which is going to start soon. Search and filtering functionality. We are working with semantic search. Lava is doing some work on it. Poor SEO. So I read comments saying, oh, I cannot find my data through Google, but I know they are in Dataverse. How comes? We know Leonid is working on this. We know this is something we have to fix. Documentation is outdated. Space limitation for deposits. We're now fixing this. Some feature seems to be unintuitive or hard to discover. So there are lots of features. Even our director in a recent meeting was asking for something. So Gary, which is the inventor of Dataverse, was asking for something. And why don't you implement this? And Gustavo showed, oh, it's here. But you just don't know that it's here. That's why with the new SPA, we can actually improve the way the user can interact. And then lack of flexibility compared to other repositories. This was very generic comment, so I don't know what it means. But we are also increasing interoperability. But there are other things that people like, of course. The openness, the access to data for free, ease of use. So it's in total contrast of this one. Reliability, the reputation and trustworthiness of the repository, the wide range of data and data types, support, good services, this is Sonia, team, the fact that you get the DOI, the fairness and open science principle, the Dataverse support, and then many people use Dataverse before even starting the research. So in my vision, it was the first icon. So even like you do the same, like you do this for your for research papers, first to see if someone has already done your research, you can do the same with your data. We just don't tell this to the people, that this is a good way to start seeing whether you have to recollect the data or the data already exists. And this is something we should push more maybe. Okay, I think that's all from me. Thank you so much, and enjoy the 2024 edition of the Dataverse Community Meeting. And now it's Gustavo's talk.
Gustavo, come on up. Here's the slide. Gustavo is going to tell us today about tools and features, give us some updates on that. Gustavo is the technical lead and architect of Dataverse. He has been on Dataverse in many roles since its inception, and in his current role, he leads the architecture and technical design of the platform, reviews code from internal and external developers, assists the Dataverse community contributors, and overall works closely with the development project manager, which is me. He began his Java programming career at the Cambridge Technology Partners in 1997 and has over 20 total years experience as a software developer and consultant.
Thank you. Let's see. Okay, there we go. Perfect. Okay. Hi, everyone. Again, I'm Gustavo. Bienvenidos a todos. Let me just start out with a couple questions because I'm very curious. How many people here, and being, community being the 10th community meeting, I see lots of familiar faces and everything. So how many people are relatively new to Dataverse and don't know that much about it currently? Is there anyone, or we have a few? Okay, there's a few, which that's good, because in my slide decks, I like to, even if it's not sure if I'm going to use it, I have a little bit of an intro to Dataverse, and I describe it a little bit, so I'll go over that a little bit for those. How many people, it's the first year at the Dataverse community meeting? First time you've been at a community meeting? Okay, quite a few. And then just out of curiosity, and I don't even know if there's that many or if we like just those of us from the core team, but how many have been to all 10 Dataverse community meetings? Do we have any? Okay, we have a few, that's good. Excellent. Okay, so let's get started. I'll start with a quick little intro to Dataverse for those who it's new. For those who have been with the community for a long while, maybe there'll be a small something you'll learn that you didn't realize. But the idea of Dataverse is it's an open source platform to publish, cite, and archive research data. It's open source and it's built to support multiple different types of data, users, and workflows. We'll see that through the presentations when the different groups talk about how they're using it for just their university or for the consortium that use it across, for example, Borealis, across all the different institutions in Canada. We started it in 2006 out of Harvard's Institute for Quantitative Social Science, and our funding comes some from internal from IQSS and from Harvard, but then also we get a lot of grants that we work in collaboration with a lot of you guys actually and a lot of the different groups that are using Dataverse within the community. We do have a core team at Harvard. Many of us are here, many are back home. And that includes, from developers to UI UX, there's metadata specialists, the curation team with Sonia, the leadership team, Stefano. Kaylin was, since the last community meeting, I think she started just before the last community meeting as the project manager. And as Stefano pointed out, we've hired 3 new developers on the core team. One thing we've been focusing a lot on is trying to also increase the community part of the core team. So now there are several key contributors from the community, and we're still working through how to make that work. But the idea is that they should have the same full privileges that the IQSS team have. Whether you're a member of the IQSS or whether you're a member of some other organization, if you're part of the core team, you should be able to review pull requests and do QA and merge things in to keep adding more and more functionality to the software. There's lots and lots of features. This link will take you to a list of features. The main thing I usually point out is that the core code focuses on the core tenets for publishing, things for getting citations, for sharing, for versioning, supporting fair data principles. While we have robust APIs that allow interoperability with external tools, I'll talk a little bit more about those, and other repository software in order to allow experts who can do visualizations and things like that to produce those apps that connect to, again, the storage of Dataverse effectively. I do talk about a few other features that I think are core to Dataverse that make it a little unique across the repository landscape, let's say. One is our concept of Dataverse collections. Really, this began as an ability to organize your data sets how you need. You can create them hierarchically. And so, example, different installations operate differently. One from university might just have a Dataverse collection for each of the departments. Something like a consortium, again, will have a different Dataverse collection at the top level for each of the institutions that use it, and then structures under there. More and more, though, we are also seeing that we're using Dataverse collections to define the different rules that apply to these collections. Things like which metadata is appropriate for the astrophysics department versus the social science department, the different permissions, whether it's a individual depositor or whether it's a journal, for example. And we'll talk a little bit more about each of those. And then when I talk about features from the past year, we'll see a few of them which are, as we add new features, we often have them to be defined per Dataverse collection. So as I said, the metadata can be dynamically defined. We store the structure of the metadata in the Dataverse, and so that allows us to be domain agnostic, and you can basically use it to create a form of whatever interesting metadata you need, and often supporting different standards. The permissions, again, are also flexible, and the idea is that, again, an individual researcher will want permission to create and publish in their own Dataverse collection, but not allow anyone else to. A journal will want other people to deposit, but will want to restrict who can publish to the curation team of that journal. And so the way we define permissions and everything, you have that flexibility. You can also create groups that are either statically defined or dynamically defined. For example, at Harvard, we have a group that if you've logged in through Harvard Key, which is your Harvard login, then you have access to download a lot of data sets that you wouldn't otherwise have access to. And then the last big thing is our APIs. Since the Dataverse 4 release, we really focused a lot on APIs. And now with the upcoming SPA, everything will be possible via APIs. So we do have APIs for search, for deposit, for access. Anything you can do through the Dataverse UI, you'll be able to access through the APIs. And that's how these external tools that we often talk about communicate and allow, again, these data visualizations, these extra configuration tools, things like that. The technology is recently upgraded since last year to Payara 6, the latest version of Payara, the application server we use. We use a lot of Java technology. We've upgraded, and I'll talk a little bit about that when I talk about what we've done last year. The big thing is, for the first year in many times, I've added a new line here, which is the front end, the SPA, that's coming soon. So eventually that JSF prime faces will go away, but not quite yet. We're working on that. Okay, next let me talk a little bit about the community. I won't go too much into it because Stefano already talked about some of the numbers and Phil has a presentation about the community. But one of the big things I like to see is how many people have contributed to GitHub. So we have over 185, I think the number was 189 contributors when I looked. So, and every time, obviously that keeps growing, but we're approaching 200. But the community is much more than that. It's all of the people, not just who contribute, but who use Dataverse, and a lot of you, everyone here is part of that community. And we operate with the community in many ways. We do workshops, we do UI, UX testing, we've got the GDCC, which there's, we'll hear updates later from Philip on that, and John and Jim. There are many ways we communicate. We have Google Groups for email, we have Matrix. I think I need to add Zulip on here, and community Slack. We also have the community calls once a month, and we have the annual Dataverse community meeting. And the other thing is, maybe let me throw out a little bit invitation, is on Thursday, every year at the community meeting. I don't think it's the 10th one because I don't think we started in the first year, but we have the Dataverse Cup. So, we're sitting around a lot and, then going out and eating and drinking. So, this is a chance to get out there, stretch your legs, run around, be like Messi. And yeah, so I think it's Thursday at 5 o'clock. It's open to anyone. You don't have to be good at soccer. You don't have to care. It's just, like I said, it's a chance to run around and interact with your fellow community members in a different way than you might ordinarily interact. The GDCC exists to support the different repositories and how they can work together. Again, there'll be more of that when the GDCC talk comes. And then the numbers, the one thing I'll point out, Stefan already gave the numbers here, but we always keep pointing out the number of installations because that's a number that we can easily track and that we know. One, it's only if they self-report. A lot of times when we come to these meetings, we learn of new installations we didn't know existed, and we're like, oh, why didn't you tell us? Let us know. Let us add you to the map. And the other thing is, as you know, Harvard Dataverse is open to many. Borealis is across Canada. So how many institutions are actually using Dataverse is actually in the hundreds and maybe even already low four-digit number is my guess. And probably something we should try to work on tracking is actual number of institutions because I think that would be a really useful number to have. But currently, like I said, we have this one because this one is one that we can easily track and graph and see the growth of. I won't go over this because Stefano, I think, covered it. And then now we'll move on to new features. Okay. So since the last community meeting, which again was 9 months ago, not a full year, but we have had 3 releases. 5.14, which was in August. 1 month later was 6.0, and we'll understand that in a minute. And then most recently in December, we released 6.1. And the reason 5.14 and 6.0 are so close is because we developed them in parallel. And the idea was we wanted to do an infrastructure upgrade for 6.0, and we'll talk about 6.0 in a second. But at the same time, we didn't want to force installations that wanted some of the new features that they've been waiting on to have to do this bigger installation, bigger upgrade. So we worked them on in parallel. We released 5.14 with a bunch of new features, and then we released 6.0 shortly later with the same feature set, but with the infrastructure upgrade. So here's some highlights of 5.14. You can see there's a link to see the more details of the release notes. But registering PIDs for files for select collections. I'll talk a little bit more about that one in detail. We added signposting for Dataverse, link for support for permalinks, a mechanism for adding external exporters. We have new APIs for creating data sets with incomplete metadata, support for grouping data set files by folder and category tag. We've improved the performance of indexing. We're always trying to help improve the, beyond just adding new features, improve what already exists there. Some changes to the PID provider JVM settings were added in 5.14, and really that's in preparation for this future feature that we're working on for 6.2, which is to be able to use multiple PID providers at the same time. So, one Dataverse collection would use this PID provider, another one would use a different PID provider, or again, maybe this data site as well, but with a different prefix. And then we've added this new external tool type, the query tool type, which Stefano talked about with the ASTA data, and I'll talk a little bit more about that, but again, not too much because we have other AI talks. So this feature just I think is interesting. Now we can register PIDs for files and select collections. This is one of those where the Dataverse collection model works well because then we can say for this collection, we do want to register files PIDs. For this other one, we do not want to. And so you can define that at the installation-wide level, and if it's enabled at the installation level, you can disable it for certain collections. And if it's not, if it's disabled at installation level, you can just turn it on for different ones. So there's a lot of flexibility, and it uses the admin API to set it up. You can see here's the screenshot from the guides explaining how to set it up and configure it for your installation. So Dataverse 6.0, like I said, same functionality as 5.14, released a month later, but the main idea is we upgraded a lot. The Java version that we now use went from 11 to 17. We upgraded to the latest PyR, get all those security fixes that they have in there, and some other nice bonus features. Solr we upgraded to 9.3. We decided not to upgrade Postgres. Postgres 13 still remains the tested and supported version, though there are groups that have used later versions and it does work. It's just this is the one that we can say officially that we've tested with and support. And here's a URL for the release notes for 6.0. So while we were doing that, of course, more and more features were being worked on, but we had to kind of say, well, hold on, we're going to get 6.0 out, and then we'll move you guys into the 6.1 release. So 6.1, I think, in my mind, has a lot of juiciness. The first two, guest book request and collection level storage quotas, I'll talk a little more about those. But we also, as Stefano pointed out, we continue doing the support for Globus. We've added JSON schema for data sets. We've made improvements to the OIDC Connect, OpenID Connect infrastructure. Again, more Solr improvements to help performance and help handle interesting situations there. We've also, again, continued to focus on how we can connect with these external tools. So we have new releases of Dataverse previewers, including a Markdown previewer. I'll talk a little bit more about that when I talk about new tools. And we have a new type of tool, which is we always had the ability to, well, not always, but for a long time, to configure tools for the data file level, but now we have configure tools for the data set level. And we'll see an example of that briefly, shortly. So the first of the two features that I'm going to highlight for 6.1 is guest book at request. So previously, when you downloaded a file, you could set it up so that you would present the downloader with a guest book, basically a little form asking some questions of, hey, who are you and why do you want to use this data? Now that's been set up so if you want to, you can configure it to come up when they actually ask for access to the restricted files. So you can learn why do they want it before you grant them access. So the default is still to show it at download, but this can be configured and it can be set up so it can be overridden for individual Dataverse collections, or it can be overridden for individual data sets. So that's a nice feature that was worked on by Jim in support for the Australian Data Archive. The second is collection level storage quotas. And so this is a fairly experimental new feature. We haven't yet set it up at Harvard, and I don't know if anyone has set it up yet. But the idea is, as we're growing bigger and bigger, we want to try to limit, different aspects of how Dataverse installations are used, just because, again, in this example, it's about limiting storage, adding storage quotas, because storage can be expensive, and we want to make sure that, hey, Harvard Dataverse is open to the world, don't abuse it and upload a petabyte of data. So we can define storage quotas, we can set up a sub-collection, you can override it a sub-collection to give it a higher number, or a fixed number, so that even if the higher Dataverse collection has let's say 10 gig as its storage, you could say, well, this one individual sub-collection of that should at least be able to have 3, even if all the other collections within that parent Dataverse collection are using most of the 10. So they can't take away from that one sub-collection. The users do get informed of how much they have allocated when they're uploading the files. And like I said, it's still fairly experimental. You can see there's a lot of information in the guide about it, explaining how we're envisioning it and want to see how it works. And that's a link to that page over there. Okay, new tools. Recent tools that we've added, a lot of new file previewers. We have a new rich HTML previewer, ROCrate, and a few others. There's also been work to upgrade the Globus transfer tool. It started out as a prototype, was working very, very well, but not really production level. We'll hear a lot more about that when Jim presents later about the Globus and things like that. The query type tool, which again is for tabular data, and Ask the Data is our example of that. And then the data set level creation tool, I'll talk a little bit about Turbo Curator. So the Globus transfer tool, again, I won't hit this much because there's a whole separate presentation about this, but the idea is to be able to go beyond the limits of uploading data to get big data in, maybe just upload the file metadata to help discoverability. That's very important for sensitive data, or if the data is extremely large, or if you want to be able to integrate with computation so that you leave it at the source, things like that. Ask the Data, Stefano already talked about this, and there's a talk tomorrow about AI in Dataverse. But the basic idea that I think is query tools really are almost a subset of previewers. It's a way of previewing information in a data file before you actually have to download the whole file. We thought it was interesting enough that it got its own little robot cute icon. And the idea is conceptually is we want these query tools, we expect these query tools really to rely on a lot of these new AI technologies and things with ChatGPT and everything going on with OpenAI and stuff like that. And then I talked about the data set level configuration tools. The reason we actually added that feature was in fact to support this tool, the Turbo Curator, but obviously now it enables us to add more tools that are configurable at the data set level. But the idea here, and this is also another using AI because they use AI. If you're a depositor of data, you have your data, you've deposited it, you can then go to this tool and it will make recommendations for you based on OpenAI's ChatGPT and ICPSR best practices to provide you a better title, a better description. Hey, these are keywords that from all the information you've given me and all the metadata I have that the tool suggests use these keywords. And it gives you, I don't know if you can see there, but it says like, why has it made this suggestion? So you can learn why it's suggesting it to see if it fits your needs, or ChatGPT doesn't always get everything right, so maybe it doesn't fit your needs, but you'll have a better understanding. And we actually already have it turned on in Harvard Dataverse and are using it. So if you're an installation and haven't, I encourage you to consider adding it. Okay, so I think my time is running, so I'll go quickly through like future plans. Again, there's a whole talk, I forget if it's Thursday or Friday, but on like the future. So there'll be more details. Main thing is at Harvard, we do a bunch of different things. We are supporting Harvard Dataverse. We're also supporting community development and facilitating PRs that come from the community. One of our tasks to do in the next few months, now that we're done with 6.0 and 6.1 and this new release schedule, is we're going to revisit old existing PRs, see what state they're in, reach out to you. So if you have an open PR, just be aware we'll be communicating soon with you to see like, is this still something of interest? If not, if it is, help us figure out to get it to merge with develop and we can run it through the process. If it's not, we might just close it. We're working on the NIH Gray project initiative. And then we always have other Dataverse related projects, all this AI stuff and this, for the MOC that Stefano described, things like that. These are the different program activities for the Gray. I think I've presented this slide at many other times, so hopefully you've seen them, but we keep working on this. Our release schedule and plan, again, our most recent release was in December. This was the first release under this new idea that we want to basically be able to announce releases ahead of time so that you guys can already be ready and know, hey, this release is coming up. It's going to be available this and this date or this and this week. Our next one is 6.2. We're planning it for late March. It's going to be in conjunction with the SPA beta. And here's a link to the GitHub issues that are going to be in there so you can see what issues have been merged or being worked on that have a 6.2 milestone. And beyond that, we're going to continue with this timed release. We're probably happy with 3 months. I think we internally need to decide if that's the right schedule, but it feels like it's been working. And again, continuing with the SPA so that we can eventually retire the JSF UI and have the SPA be the sole default UI that's provided by us. Here's a link to the roadmap if you want to learn more about the strategic goals that are coming out of IQSS for the project for us, and gives a little more detail about what we're working on and what's coming up in the future. And with that, I thank you and welcome again. Bienvenidos. And I look forward. Any questions you have, feel free to come and catch me during one of the breaks, or I'm sure we'll talk a lot. And again, Dataverse Cup Thursday.
Thank you, everyone. So we get a coffee break if you promise to be back here directly in 10 o'clock, 11 o'clock on the dot. Help usher your community that's outside back in. They're still outside. All right, so our next speaker is Phil Durbin. Everybody knows Phil. He's our software developer forever. I think I've known Phil for 20 years now. Little over 20 years. Okay, 17 for him, over 20 for me. So, Phil has been hacking on Dataverse full-time since 2012. When he isn't writing code, he's herding cats in the Dataverse community, answering questions via email, chat, and community calls. He has given talks about Dataverse in Jakarta, Berlin, Brussels, Lisbon, San Francisco, Chicago, and his home base of Cambridge, Massachusetts. So let's welcome Phil for our first ever real community updates that is now an integral part of our plenary day for our annual meetings.
Thank you, Sonia. Yeah, I like this idea that if I'm always giving the community updates, it means I get to go to all these trips all over the world. So thanks for that. Let's see, I'll get the slides advanced. Today I want to talk about the state of the community, and we're going to look at some numbers, and then dive into those numbers in a little more detail. And, oops. Oh no. I want to give a lot of time to pull requests and issues, and then of course some crazy ideas. So it's an election year, and you know, in the Constitution in the U.S., the executive is compelled to, from time to time, give information about the State of the Union. And in the past several decades, there's been this tradition that the president will get up and say that the state of the union is strong. And likewise for us, the state of the Dataverse community is strong. We've already seen, when I made this, the installation numbers are so much in flux that back when I made these slides last week, I just put 110 plus installations, but as we saw, 115, 35 countries, 425,000 data sets, around 1,000 subscribers to the Google group, and our new chat room, chat.dataverse.org, powered by Zulip, about 100 people in there so far. So these two numbers now about issues and pull requests, this is filtered down to just issues opened by the community and pull requests opened by the community. And some of these numbers are so high and incredible that as I was practicing my talk last night, I went and just fact-checked myself. Are these correct? Did the community really open, 1,600 GitHub issues? And did the community really open 1,300 pull requests? Is that possible that we got that many pull requests from the community? But it's true. This is ever since the current generation of the Dataverse software was started. The first commit was November 1st, 2013, so just over 10 years ago. So it's just an incredible amount of effort being poured into our software thanks to the community. Thank you. And as Gustavo mentioned, maybe it's 186 or 187 now, but definitely over 185 contributors to the main code base. 186 videos on Dataverse TV. So I guess that means if you're a contributor, you should also put a video on Dataverse TV or something. And then similar numbers for community calls. So since 2016, we've been doing community calls. We're up to 189 of those. It's amazing. And then 5 active working groups. As you'll see later in this community meeting, there'll be a hybrid meeting for each of these groups. Okay. And last but not least, 10 years of community meetings. So, yes. Round of applause for that. This is a picture from the first community meeting in just across the street from our building in Cambridge, Massachusetts at Harvard. And then this is a picture at the bottom from Braga, Portugal last year. So very happy to keep these meetings going. Okay, we've seen this map already. Maybe something new is just the 35 countries on the left, so you sort of can quickly see a breakdown that we're huge in Brazil, and as well as the US, the Netherlands, Germany, but France, where we've got lots of installations all over the world. It's wonderful. And I wanted to give a special shout out to Sherry Lake. Where's Sherry? Yes, she's been helping out, volunteering her time with this map. Julian, of course, maintains the map data as well, but for Sherry, it's a volunteer effort, so I just want to say thanks, Sherry, for all the work on the map. It's much appreciated. Okay, and we've seen similar graphs of growth over time, of number of installations, and then by year at the top. You can find these charts at the bottom of the link there if you want to take a look. And then moving on to data sets. So I put this Wikipedia icon here because when Wikipedia was new, I thought this is kind of cool. You know, instead of this, we had a World Book encyclopedia at home growing up. But now there's a encyclopedia online, and it's growing and growing. And I remember when they reached 500,000 articles in English in Wikipedia, and what a big momentous occasion this is, 500,000 million. And I feel like we have a similar story with Dataverse, that together, collectively, we are adding data sets to this corpus. And just like Wikipedia, we continue to grow more and more articles, more data sets all the time. And you can find these numbers, as was mentioned earlier, at dataverse.org/metrics. There are more metrics to find there. And yeah, well, just real quick on the Google group, as I mentioned, we're up to almost 1,000 people, which is just great. Like, if you want to get the word out about something, the Google group is really the place to get your message out, because you'll reach so many people. And we've seen quite good growth in 2022, 2023. Lots of people signed up, so please sign up if you haven't already. The link is at the bottom. It's called Dataverse Community on Google Groups. And then on to this new chat room. I sort of previewed this a little bit in Braga, Portugal last year, but when I started on the Dataverse team 11 years ago, the place to be was IRC for an open source project. So that's what I ran for many years, this IRC channel. And then we did switch to Matrix for a little while, but then I found this software called Zulip, and we're sponsored because we're an open source project. So we have our own space. It's all archived. And just like the Google group and GitHub issues, it's open in the sense that if you post something on Zulip, you can easily cross-post between the Google group and GitHub issues. So it's easy to make all of your information discoverable. This graphic, by the way, was created by my daughter. I said, I want some cute animals talking to each other. Can you help me out? And yeah, that's where that was born. Just to give a little preview of how it looks like this. I actually have a capital D, Sonia, Dataverse 2024 hashtag going on Zulip. So these are pictures from last week. There was a volcano that went off recently, and Jim found the data on the, don't worry, the ash is moving away from Texcoco, we're fine. But there are more recent pictures now from a sunrise over Summit to like dinners and nice food pictures. So please feel free to jump into chat.dataverse.org and post pictures and whatever, or post them to Twitter or X as well. Let's see. Oh, and then just some more up and to the right, similar story, good growth of all the chat metrics as well. Okay, now I want to get into pull requests and issues. And the main thing I want to say is thank you for all these pull requests. I'm already forgetting it was like 1,300 pull requests or whatever. Ton of pull requests, very much appreciated. Thank you. But I will say that it gets a little difficult to manage at times. You see we have 102 open pull requests. And you know, what are we supposed to do with all these pull requests? Well, my first thing is to, when I put my community hat on, I want to know where are these pull requests coming from? Which ones are coming from the community? So I make this little app that I call Skipper, because it skips over all the core developers like me. It says, I don't care about your pull request right now. I got my community hat on. And so from here, at least I can filter it down from 102 to 64. So it's a little bit of a more manageable number. Then from here, we're going to take those 64 and get them onto our project board. But I put this slide in here because as I was working on my talk, I realized it wasn't super easy to find this project board. So I added a link just last week to our main, this is on the bottom, is our dataverse.org website. If you go to software, project board, there's now a link to find it. And also the README. So on the main README on GitHub, you can find the project board there. From the project board, the default view is actually the sprint board. Don't worry about that. Here I'm clicking right away to the global backlog. And then this first column you see is what we call the community backlog. And my name is here. And so this is me trying to manage the community backlog best I can. And you can get further information by clicking on the community tab up at the right. And here you'll see some details of all the various pull requests that I've put into this community backlog column, and I try to give them all a size. So smaller size is better, of course. It means that the pull request should move. It's my guess of how quickly I think the pull request could move across through our development process. Yeah, and I brought cards here today, so if your pull request is not getting enough attention, come find me or email me later and let me know, or find me in the chat room. And I'll try to put it higher up and try to get these things prioritized. Okay. So that's fine, pull requests. But what about issues? I think we saw there was like 1,600 issues from the community. That's kind of all time. A lot of these have been closed already. We've already fixed a lot of bugs and such. Now, 461 of them are still open. So that's an even bigger number than 102 or 64. What are we supposed to do with all these open issues? We want to serve the community, but as Stefano points out, the project's funded by Harvard, and we have grant deliverables and all sorts of things. So we're trying to strike this balance of keeping people happy. So an idea I had a while ago was to say that everybody should have their own project board, every installation. And I talked about this in the past, and the way to find the project board, if your installation already has one, is to go to the map, click on the details, and there should be a link called Project Board. And I'm actually showing Dimitri's project board. We talked about having a community call about this, that maybe you would present this whole thing. Because I love this board. It's very well organized. We have various columns, interest, needed, important, top priority, plan development. Plan development is actually super helpful because I can go to Dimitri's board and find out, his team is actually going to be working on this or that issue. So we can expect a pull request. We can expect some code from his team. But I got to say that this whole scheme has become a little difficult to manage. I was calling it in my head kind of like a code name of druthers, as in I'd druther you work on issue this or that. And I have some Python code that does compile it all into a spreadsheet, so you can see this issue has so many upvotes. But as I was talking to Kaylin about this, there's a new project format for GitHub. So this is all working under the old classic format that I'm not sure will be supported forever. And we might be able to work together and figure out using the new GraphQL API, we'll get the new thing going. But I thought maybe all of this, well, so one thing to be clear, this board from Dimitri is still very useful. I want you to keep doing this. I'm more talking about the aggregation. The nice thing about your board is that when we click on any of these issues, we can see if the issue is on other people's boards as well. So it's an instant feedback to us, like, oh, it looks like 4 different installations of Dataverse want this issue. But a simpler way with GitHub these days is to just simply give a thumbs up on the issue. I think you've been able to do a thumbs up on issues for a while, but what's somewhat new is that these days you can go into the count of issues, then click on sort, and then sort by the different emojis. I guess you can sort by heart or eyeball also, or ta-da, rocket ship. But if you sort by the upvotes, this is just a simple mechanism where we can easily surface which are the issues that are most have the most thumbs up. It actually happens to be this one with 11 about you want to be able to upload a zip file and have it not unzip, which we've heard about for years. So it makes sense that that's the most upvoted issues. So I don't know, I haven't really even talked about this with the team yet. It's just an idea I'm floating out there that perhaps we should just simplify things and just go for the upvote. The thing you lose with that is you hover your mouse over the thumbs up and then you see things like foo barbecue and poi kilo therm. And so then I'm losing my nice knowledge of these 4 installations, which are easily recognizable, with this issue. And instead we have sort of a grab bag of names. So the next crazy idea was, well, maybe we should have some sort of like some way to track to better understand who's in the community. So I built this little thing called Dataverse People. It's still very much a prototype, a proof of concept, but at least it's a way for me to show the association. So I know that the poi kilo therm is actually this guy, Oliver Bertuk, who's on the core team, and he works on this Dataverse installation. So it could be a way to still have the thumbs up upvote, but then have some way to look up. We could write scripts and say, translate all these thumbs up. That 2 of them are from Borealis or something. Different installations of Dataverse. Okay, so that was issues and pull requests. And then since I mentioned Dataverse TV, I would just remind you again of its existence, dataverse.org/DataverseTV. New content coming in all the time. Stefano mentioned his talk at the Massachusetts Open Cloud Workshop just last week. It's already on there, so feel free to check that out. This is powered by a spreadsheet, just like my people site and Dataverse TV. And then community calls. Yeah, I mentioned we had quite a few, 180 some. Things have changed a little bit recently where we used to have these every month, but it was sort of becoming a little bit too much. And so we had a Google Doc and some soul searching about what do we want to do with the community call. So you're welcome to check that out. And then now, thanks to Kaylin, we have a new planning document. That's the second link where we are ahead of time planning who's going to be in charge of the community call. So instead of one person always running the community call, we're trying to distribute that work. And then I just want to make sure people know that we have this Google Calendar. You can find it linked from dataverse.org/events. So of course you'll see this very event here at Summit, but a lot of the working groups will post their next meetings. So it's a good way to know how you can get involved in the Dataverse community. And speaking of working groups, as I've mentioned before and you've heard before, there are going to be hybrid meetings during this conference. And a lot of these working groups have websites. You can check them out for more details. And this site, this gdcc.io is relatively new. It's sort of the new website for the GDCC. And there's a new page there on working groups. So that's where you can find this list and get involved. I wanted to close with just some thoughts on our values. One of the greatest things about the Dataverse community to me, from where I sit, is the generosity I see. So I'm always seeing pull requests coming in, ideas coming in the form of issues. So I want to thank you for that. Responsiveness. I try pretty hard, like on the Google group, to at least acknowledge, like, I hear you. I'm going to try to help you. I'll give you a pointer here or there. I think it's a value that we all share and appreciate. And then fearlessness. This is back to Wikipedia. They have this slogan, be bold. Like if you see a typo in Wikipedia, just click edit, fix the typo. And I'm seeing the same thing in the Dataverse community where people aren't shy about opening issues, obviously. And I think we should encourage that. We should say, if you have an idea, please let us know. And yeah, I want to thank you for the time.
Continue with the agenda.
Question from Slava.
How do you feel if we'll have 1,000 people contributing to Dataverse?
1,000 people, that'd be great. Yeah, that'd be wonderful. So we're at 187, I think I heard, so. Oh, and one point on that is that 187 to the main repo, but we have lots of repos, lots of different, side projects and things, so a better count would actually be to collect the number of, deduplicate them, but make sure that we were counting everyone, whether they're contributing to this repo over there or the main repo.
And second question, what if industry will start to use Dataverse, like Google, Facebook, and others?
I'm sorry, you said Google, Facebook, and others?
Yeah,
What?
if Google will start to deposit in Dataverse.
Oh, if they started pushing it, promoting it, oh, that'd be wonderful. Yeah. We're working with Google right now on a couple different fronts. Stefano showed Google Data Commons, which is a nice project we're starting to integrate with. There's also this croissant format that I know you and I have talked about. So.
Yeah, this is why I'm asking.
Yeah, I think there's potential there for sure.
Yeah. Okay.
Thanks.
All right, so now we have GDCC updates. Dr. Myers, Conzet, Crabtree, make your way up. So Dr. James Myers is our software designer, developer with the GDCC and the Dataverse Project. And we have Philip at the UIT, the Arctic University of Norway. Philip is the senior research librarian at UIT, the Arctic University of Norway. And as a member of the research support team at UIT Library, he devotes much of his time to working on open science, especially research data management. He's the repository manager of Dataverse NO and of the TROMS repository of language and linguistics. He's the chair of the Global Dataverse Community Consortium Steering Committee and part of the steering committee of the Norwegian node of the European Research Infrastructure for Language, Resources, and Technology. And let's not forget Jonathan. Jonathan is the Assistant Director for Research Data Information Systems at the Odum Institute for Research in Social Science. I hope they updated that for you. They didn't. I apologize. Okay. Jonathan, and well, I'm going to stop there because you need to then introduce yourself properly. All right. So, GDCC updates on board. Who started?
Me. Yeah, hey. Hi, everybody. My name is Philip, as Sonia just said. I'll start off this updates session about the GDCC. Yeah, so this is the outline of our session. I'll have the introduction and tell you somewhat about sustainability and governance of the GDCC, and a few words about our new website, and then Jim will give you an overview of the activities and services we have provided the past year, and John will finish up with the membership update and about the budget and finances, and then hopefully we'll have some time for discussion and questions. So if you want to take some notes, please go to tinyurl/GDCC 2024. Okay. I guess most of you have heard about GDCC, but just let me give you a brief recap. GDCC was introduced at the Dataverse community meeting back in 2018. So where John Crabtree and Mercy Crozas, Stefano's predecessor at IQSS, discussed this in a breakout session, the need for more structured support for the Dataverse community to add some governance structure and also some potential services and expert groups. And the vision of GDCC is to help organize and coordinate existing community efforts and provide a collaborative platform for community members to leverage economies of scale to support the Dataverse repositories around the world. And who is the GDCC? Basically, it's all of us, you, me, everyone contributing to the community. And we encourage you to join community efforts like working groups, interest groups, attending the community calls, ask your questions in the different channels that Phil just presented. And we encourage your organizations to join and contribute to the GDCC. And so far, the GDCC has been run as a lightweight, informal lightweight organization with several working groups and interest groups. We have Jim, who is doing most of the technical work for GDCC and coordinating community efforts. And we have a steering committee, which consists, apart from me, of John, Stefano, and Steve McEachen from Australian Data Archive, who couldn't be here today. And also Jim attends our meeting, and Kaling usually meet once a month to discuss issues. So let me just tell you something about sustainability. We discussed this quite extensively at the last meeting in Braga last year. So as you have seen on different slides presented by Stefano and Gustavo and Phil, the community is growing, the numbers of installation is growing, and so on. So that means also that there are different kind of needs, expectations, level of commitments, and so on across the different installations and community members. So I repeated this figure that you have seen several times already. So you see that the number of installations is continuously growing. And I just pulled out where they belong, which kind of region of the world. And as you see, actually, most of the installations are now situated in Europe with about 43%. Yeah, and there is also a lot of other indicators of growth. Phil helped me pull out this, the number of GitHub issues just submitted last year. So as you see, the total number is 542, and we had 327 pull requests that were merged last year. And as Gustavo told you and Phil, there has been a lot of other activities going on the past year in the community. So, and this popularity, this growth, continuous growth of the software and the community also poses some challenges to the sustainability of both the community and the software. And in particular, we need to address questions like how to make sure that the Dataverse software and also the larger ecosystem of associated integrated tools and services are developed and maintained in a sustainable way. And also how to further empower the GDCC to contribute to this sustainability of the community and the software. And for that, I think we need to kind of add some more formal structure to the community. And to address some of these challenges, last year at the community meeting, we decided to establish a sustainability working group, which was then established in August last year. And the mission is to provide evidence-based, community-reviewed, and consensus-based recommendations on how to sustain and grow the Dataverse community. And these recommendations will be very important for the further development of the community. And as you have heard by Sonia, we will have working group meetings, parallel working group meetings, and the sustainability working group will have their meeting on Wednesday, early in the morning, local time. And if you have any questions or comments, please reach out to the co-chairs of the working group, sustainability working group, Duverte or René, and I think René isn't here, but Duverte is here. So just reach out to her. Yeah, and we also discussed the idea that we should to kind of start implementing some of the recommendations once the working group will provide them. We should reach out to the Dataverse community, to the installations, to the organizations that run Dataverse for some bootstrapping funding to help us formalize the global Dataverse community consortium. So Duty has prepared a slide on this, which we will show you at the meeting on Wednesday. Yeah, so the idea is to reach out to your installation, so just to give you a heads up about that. Yeah, and a few words about the new website. Some of you may have noticed that we have got a new website. We had some issues with the provider of the old website we had, so we had to change provider, and at the same time we also changed the URL, which is now gdcc.io. And thanks to Oliver and Phil to help us with the technical support to make this happen. And if you have any feedback on how to improve the website, just let us know. Yeah, and then I'll hand over to Jim for activities.
Thanks, Philip. So I want to give you some sense of what we do technically in GDCC, but again, it's a very hard problem because as you hear from everybody here, right, we all work very closely together. So there's IQSS, there's the core team, there's GDCC, there's the community, and assigning blame or, done? Oh, I got to get closer yet, okay. Assigning blame or fame for any of this stuff is really hard to do in isolation because it's all tied together. But that said, I do want to give you some sense of what when in 2018, what we wanted to do is it was really a recognition that the community was growing, that there were more groups out there that were trying to install this stuff and trying to go from the manual and boot up from there. There were many groups that were starting to get their own developers and were starting to contribute to Dataverse. And they may, at the beginning, have not had deep understanding of the insides of Dataverse, and so they were trying to do things that were very difficult for them to get started on, but if they just had somebody to talk to figure out how to tie what they wanted to do into Dataverse, right, they would go 5 times faster. So GDCC started trying to bring people like me in, with Don from Odom trying to help with those kinds of install and technical issues and development issues. And you can see we've kind of gotten involved in various ways with the 2018 was when the working groups started up, so we were trying to help contribute to the working groups and make sure that there was a document coming out of those and there were some action items and that we came up with a design document. So things like the external vocabulary mechanism, we tried to, there were drivers in the community, but we basically tried to drive that to completion. And again, with Slava and my help and so on, we basically pushed that mechanism in, and it's now a usable feature in Dataverse and so on. So again, you can read this better than me going through all of it, but we're basically involved in all the stages here. Don is involved in sort of getting the infrastructure and things set up that Dataverse uses for builds and tests and so on. We're basically around in all of this. And again, I've mentioned the community coordination. Phil mentioned briefly that we talk about Dataverse, which is in one GitHub repository, but there are actually, I haven't even counted, but there's 20 other repositories of Dataverse-related tools, from anything from the DV web loader that allows you to upload whole folders into Dataverse. Exporters now are something that's external, that metadata export formats can be done in a separate repository. Easy Dataverse is another one that again, Jan and others are, other folks, what's in these repositories may come from the community, but somebody had to click some buttons to get GitHub set up and going. So sometimes that's what we're involved in. And again, you can read on through. As I mentioned, there's also Jenkins AWS infrastructure that GDC is helping with, and again, in working groups and so on. We also kind of above that baseline, one of the things that we did with GDCC is to try and get to where if you were a new place, again, a lot of these things, Dataverse is getting started up in the library. They have a limited staff, and so either the initial setup, or if they've got a Dataverse and they want to go and migrate through several versions, that's bigger than their normal staff availability. So if they could hire somebody for short term and basically get some help going through those things, they could go a lot faster. So this sort of thing where those sorts of either training people to do that on their own or helping with the support of that, there have been a bunch of institutions, and basically being a GDCC member, and then you're able to basically buy short terms for people to help out. A lot of this is Don going through upgrades and so on. On the programming side, that's more what I've been doing, but again, if you may not have programmers at all, or you may, again, have programmers who are working in some aspect of Dataverse and then you want to feature in another aspect that you really don't have the expertise in. If you can get somebody to do it for you, maybe it's quicker and cheaper. So again, we've worked with the list of folks here. I mentioned DV WebLoader, right? That was Dataverse NO wanted the feature. I was the one who put it together, and off we went, right? And so for a relatively small, short-term thing, we got a feature into Dataverse. So it's that kind of thing over and over again. And if you're interested in that, talk to John, talk to me, talk to Don, and we'll help out. The last thing I want to do is again, this sort of one more set of slides trying to get the idea of the community and GDCC impact. And again, it's hard to get exact numbers in any of this. I think the one key thing I would try and point out in a slide like this is, there are so many projects out there that say they're open source, and then if you go look, it's 3 people from one institution funded by one grant that's making it go. And here you've heard that even Harvard is working off a whole series of grants, but when you look at the community, right, there's a lot of just operational funds, grant funds from all over the globe. And you can kind of get that sense from whichever numbers you like on here. And we have big features from Globus, which started out at Borealis, I'll talk about later today, but we helped get it in through GDCC. The guest book at request you heard about, multiple PID providers, new previewers using signed URLs. I'll try and wave the flag for this, but all of our previewers before have used an API key, which is long-lived and a little bit less secure. The signed URLs in the latest one has really tightened down security, so if you are interested, please upgrade and update to the new previewers. They'll save you a lot of hassle security-wise in the future. But all of these things are going on, and then again, if you look, there are more than, I think, 24 people in the last year or the last 9 months when I tried to get just the little bit of, the yearly update in here of PR, about half of them coming in are from the community and GDCC. Interestingly, like 70% of the features, and all I'm doing there is I basically went through and tried to look at the things that come out in the release notes. So these are like, somebody in the community wanted a feature that they needed Dataverse to do X or Y that it didn't do, and we've got a one line in the thing. A lot of those are coming from the community. So again, I don't trust any of these numbers exactly, and you've seen variants of them all over, but the community, basically the takeaway is that there's a lot of engagement there. The last one I'll point out is just security. Again, Don watches security closely, Oliver watches security closely. If we find something that comes out, we kind of quickly look and see if it's a problem and try and get those things pushed in. So, all right, with that, I'll pass it on to John for the updates.
Thanks, Jim. Before I start with some of these numbers here, if I can control the thing here. It's a little slow. Let it catch up with my book. While it's catching up with it, I would like to mention, many years ago when, actually before Mercedes, back in the world of the virtual data center, some of you from Harvard remember the virtual data center, when we started talking about the predecessor to Dataverse and where we were going, I could have never imagined as far as it's gone, and how it's now literally pushing across many, many disciplines all across the academy. And as Sonia alluded to earlier, I am no longer working just in the social sciences. UNC recognized the work that folks in this community have been doing to promote data and data sharing across the entire academy and all the different disciplines. And now we've created a new research data management core at UNC that is assigned all of the research data management all across the academy, including the health affairs and all the different data. So we look at the GDCC and all its members, and if I can get the right screen up here, I'll give it a wait. There is a screen with all these numbers on it somewhere. let me go. I want to talk about that first. Let's see if I can find this one. Nope. Because I want to show the growth we've had, and it's right before that slide. There's a slide between the two, but I don't see it. So we have now 40 members in the GDCC. We have actually added 4 new ones in the last 3 days or 4 days, and many of those are now coming from Central America. We've added Guatemala and Uruguay in the last, this past week, created their accounts and their DOI accounts there. We are adding folks all around the world. There's actually 21 countries represented from those 40 members. That's what I was looking for. That's the one I was looking for. So as you can see, we've got a spread all around the world. Of course, Uruguay and Ukraine and Guatemala added in the last few days. It has been very, very successful and growing. We're getting, over and over again, we get notes that people are growing. I think that 115 is actually a very low number. There's probably at least a dozen more in operation right now. We need to get those maps updated, because I do think there's lots and lots of them that are, I think we had a conversation at dinner last night where there was several more that we just don't even know about. So it's growing faster than we can imagine. Okay, now we're back to budget and finance. So we'll look back at 2023, and there's a little bit of an oddity this year because we started a little earlier, as Stefano mentioned. We've only been 9 months since our last meeting. But last year we ended up very well. Thanks to all the great work here, we only ended up with end-of-year accounts receivable from unpaid memberships and contracts of $4,800, which in years past has been tough. And managing the money coming in and out has been very difficult over the several years. But now we're starting to see some momentum. We had a really good year in 2023 and ended up with a year-end balance of almost $20,000 that will be going back towards support for things for this community. This year, the numbers are kind of in flux because it's early in the year. We just sent out invoices early in this year, so right now our income is only at $105,000. We have very large accounts receivables because it's early in the year, but we do look forward to having a really good year because of last year was really well. And so far, things are looking really good. And I mentioned before, we have 40 members, and we have a negative balance here, but this is very, very early. Our data site invoices, we have some that have yet to be paid, but it looks like we're also going to end up in the positive for this resource. This is a service that not all members take advantage of, but you can. I will mention that DataSite contacted me over the last year since our last meeting, and they're interested in talking with the community. If anyone here is interested in assigning basically IDs to samples using the international generic sample, as part of GDCC and as part of DataSite, that will allow us to do that as well. That's outside of Dataverse, but if anyone is interested in that, I think that we should embrace that because that's a great work that they're doing at DataSite. So let me know if you're interested in. I can get you in contact with Rory, and we'll figure out how to proceed if you need that service. And contracting, it's still, excuse me, it's still mighty early, and contracts come and contracts go. We've been working closely with Stefano and the folks at Harvard to make sure these contracts continue. We've got lots of those ongoing, and next year when we wrap up the 2024, I can have all the numbers for that one. So membership for 2025, we always try to announce it a year ahead so people can plan. There's no change. It'll be due January 1st of next year, so that won't change at all. There is a proposed change to the DOI fees, and this is because DataSite has made a change. It actually will help many of us. Previous to 2025, DataSite charged a penalty fee for organizations that went over 10,000 DOIs. So if you did that, then you had to distribute that fee across the folks that are doing that. Now they do not. I'll show you why they've changed that. But these will be the new structures for most of our GDCC members are in this range, and they don't go over 100,000 DOIs per year. That may change if you start assigning file level DOIs. So if it does, so for example, you will have to start paying larger and larger fees if you get up to, for example, 250,000 to 1 million DOIs. It would be a much larger fee, and if you go over 1 million, you have to contact me, and we'll work with DataSite to come up with a good estimate on what that'll cost. But perspective, no one this coming year has went over 10,000. So it actually will be a reduction in fees for all of our GDCC members unless you use the file level DOIs, and that's when you start getting these $100,000 ones. I mean, 100,000 DOIs a year ones. And of course, more information, go to our website, talk to anyone here. Most everyone knows the community. The community is a very close-knit community. So please contact us, reach out if you want to find out what it means and if you need help, you have a neighbor who needs help, just let us know and contact us anyway. And I guess we'll do some questions now.
I wanted to ask about the Ukraine instance that you talked about, obviously because I'm a little behind on the new instances. Do you know more about the group and how they're able to function given what's going on over there?
I don't know a lot about that group. I do know that they had a national bill that went forth that said they must do this. This is funded by the government. So it is at a national level. They were very excited about it because their mandate requires them to get DOIs in this year. So they really needed help fast. So the emails came quick that I need an account now because we're required to do this. So I don't know much about them other than that. I suspected you would. It'd be great if you could tell us a little more. It'd be great, Slava.
Hi, John. So how does someone contact the GDCC about possible consulting, or just in general what services consulting means? I may have someone in the Bahamas that might be interested.
Absolutely. So they always can start with emailing me, and that email contact is on the gdcc.io website. To be honest, most all of this is very customizable. We have some customers that just need a little help with some programming, that need one function or one thing added or changed. And Jim, for example, did that work for the folks in Australia to change how the guest book operated because they couldn't go to the new version without that. So that was a kind of a one-time thing. We also have customers have no IT support at all. They don't have anything. They want to load Dataverse, but they don't have any support. So we come up with a package for them to not only load the system, whether it be in the cloud or it be on their local hardware, and we also train their librarians how to use it, train their customers. We can come up with a plan for all of that, and it's all customizable to whatever you need. So the first step is to contact us. Sometimes we have had people ask and say, look, I'd love to get some help from you, and it turns out the help is not that much. So we just help them and move on, and we don't create a contract. Other times, like upgrades, from major upgrades coming from 3 to 4, 4 to 5, we've come up with a plan to move people through those and ongoing support for that. For example, Johns Hopkins, we just finished some work for Johns Hopkins to help them migrate up to a newer version and manage that. And that's the great work that Don and Jim are working on. I will have to mention too that if any of you have staff members, whether they be on the technical side or the curation side, let me know if they have extra cycles. Quite often you'll have people that are partially funded by grants, and as grants ended, you're looking some funding mechanisms for those. This is the whole idea of this, is we can share that funding across our groups. So maybe, Sherry, you might need some help, but someone can support you from another organization could help and come in and help with that if you had the funding and they need the funding. So you don't have to hire a full-time person for that, and you can share a person across groups. So let me know if you have any potential for that, and we'll add you to the suite of people we call and ask.
So this is more a proposal than a question. As you know, there are some installations using handles, for example, instead of DOIs. And one of the benefits of being a member of GDCC is getting access or cheap access to those DOIs. So installations like CIMIT would like to be members of the GDCC. We would like to contribute to this initiative, but we would like to maybe have access to a different package of benefits instead of access to DOIs, because it makes no sense for us. So this is a proposal for the future. So maybe you could work on offering a wider set of services or benefits.
Absolutely, and the idea here is, in a situation like that, maybe CIMIT has an idea for a set of wider services, and they can coordinate with other folks within the GDCC, and we would come up with a plan for those. For example, I was talking with some folks earlier, maybe you have GDCC members who might have preservation issues and want to distribute data in other continents for replication purposes. This is a perfect situation. We use the same tools. We live in different continents, different areas, so we can mitigate risk for hurricanes or earthquakes or things like that. And it would be a great idea if we brought together a group of GDCC members and developed that service. And then we could come up with a mechanism for recouping costs. We're all about keeping the cost as low as possible in order just to provide the service. It's not about making money, it's a nonprofit. And eventually, as Philippe mentioned, what we really want is to create a global nonprofit that manages this, so it's basically takes the next step, so it's not just a handful of very dedicated people in a few universities to now a nonprofit that's moving this forward. But yes, that's a great idea, and we would love to entertain those suggestions.
Looking forward. Thank you.
I just wanted to elaborate about Ukrainian repository.
Yes.
So I started to talk to them, I think in 2018, about having national instance. And now it's supported by National Academy. And well, the only problem is DOI, and this is biggest concern, like was discussed. But they are ready to use it already. And they're really excited also to join community.
Yep. I created their data site account last week. They've logged in and already begun experimenting. So it'll be more DOIs coming from Ukraine. Yeah. Very interesting. Data moves forward no matter what. Thanks so much, everybody.
All right, welcome back, everyone. I know everyone is excited from the tour and the germ bank. We heard it's fantastic, so welcome back. I'm going to introduce Richard Folse, Director of Knowledge Management and Information Technology at CIMIT. He's in charge of the identification, development, and implementation of effective information and knowledge management practices and systems in the organization. He guides the establishment of successful innovation cycles to improve access to knowledge assets for both internal and external users and partners, and to increase digitization, interoperability, and process efficiency at the institutional level. And our hosts here for the community meeting.
Thank you very much. I hope you enjoyed your little excursion on campus and that you saw the rich history this institution has. To start with, I'm very happy to be able to introduce Khulud Odeh today, that she's here first of all, but that she's also going to give a keynote speech. I have put the CV here because we are already talking also with Bram earlier today. Our Director General mentioned that we are very happy to have her here and to work together towards improving and expanding how we collaborate on systems development, infrastructure, and other projects related to digital and data that she's the director of at the system organization. So from our point of view, just that you understand, we are 15 centers worldwide, and those 15 centers, of course, we have to try to synchronize as good as we can how we work together, which systems, which platforms we want to use, and how this is also organized on a day-to-day level. We work in different parts of the world, so we also have a lot of things to deal with there. So Khulud is trying to bring also some structure into that, and so I'm very glad to have you here, Khulud, and I hope that you will give us a very interesting keynote speech. Welcome once again.
Hello, everybody. So as Richard said, I probably have the easiest job, as you can imagine. But I'm really, really delighted to be here. Let me know if you can hear me fine, because I don't know how these microphones play. So I'm really delighted to be here and joining you and the Dataverse community, celebrating a milestone, which is its 10th anniversary or 10th community meeting, and hopefully charting the next chapter for this community. Today at CGIAR, as we stand at the cusp of a new era marked by the convergence of data and AI technologies, we envision a future where open data plays a central role in driving transformation and innovation across agriculture, research, and development. And I'm honored today to shed light on the pivotal role of CGIAR in shaping this future and advancing our collective vision for a sustainable, resilient, and equitable world. I learned about Dataverse last year when I visited CIMMYT, and I enjoyed, of course, the tour of the gene bank and the museum, but I learned from Jesus and Richard about Dataverse community and how enthusiastic they were about the contribution, and they told me that they're planning to host the next meeting here. So I'm really delighted now to be here. But I also heard about Dataverse from several centers and data scientists who have been really from the CGIAR family contributing and active members of it. We heard earlier today from Bram about CIMMYT and its 2030 strategy and its impact and the critical role CIMMYT plays in food security and sustainable development. So let me complete and maybe add few pieces of the puzzle to help unpack a little bit the complexity of CGIAR and who we are. CIMMYT is one of 15 centers, as Richard mentioned, making up the CGIAR, which is the world's largest global agriculture innovation and research partnerships network for a food-secure future, dedicated to transforming food, land, and water systems in a climate crisis. Like Dataverse, CGIAR is about the community and about the collaboration and the cohesive partnerships across its centers and partners. As a collective, CGIAR provides evidence to policymakers, innovation to partners, and new tools to harness the economic, environmental, and nutritional power of agriculture. We have unequaled partnerships network of more than 3,000 partners from national governments, academic institutions like Harvard, global policy bodies, private companies, and NGOs. And we have local presence in 89 countries with a deep knowledge of customs, values, and market operations in developing countries. And over its 50 years, CGIAR contributed over 60+ innovations that literally changed the world. CJRC research centers have together built up the largest and most frequently accessed network of gene banks, one of which you saw earlier this afternoon, and summing up to over 770,000 germplasm or accessions that are accessed across the globe. And CJR 2030 strategy for research and innovation builds on CJR's track record across its center and collaborating partners to deliver impact and lifting hundreds of millions of people out of hunger and poverty. And the strategy looks at the work we do across and is anchored in three, we call them action areas, to drive systems transformation for food, land, and water system. And these action areas are system transformations, a resilient agri-food system, and genetic innovation. And it aspires to contribute to impact in 5 impact areas from the Sustainable Development Goals. Of course, nutrition, health, and poverty, and food security is one, but also we look at poverty reduction, livelihoods and jobs, gender equality, youth and inclusion, climate adaptation and mitigation, environmental health, and biodiversity. And part of the strategy was also reimagining the way we work as CJR, because we realized that also to really meet a very ambitious goal for 2030, we cannot continue with business as usual, even with a lot of the innovations and partnerships we had. And it identified 7 new ways of working. And I'm not going to mention them all, but I'm going to touch on one, which is dear to me. The 7th way of working that CJR had in its strategy is centralized on the utilization of digital and data innovation to revolutionize food, water, and land systems and catalyze positive change on a global scale, making the digital revolution central to our way of work. And for me, that's what sold me on joining CJR, when I saw that one. And I wanted to really be part of leading and bringing that revolution to CJR and its way of working. And in that vision, we envisioned doing this, or making this digital revolution central, through 3 areas, or 3 pathways, let's call them. The first one is really leveraging digital innovations and technologies. As we recognize, there is a global proliferation of digital technologies as game changers. So by harnessing tools like big data, AI, blockchain, we aim to transform how agri-food innovation is conducted. This involves not only enhancing our research capabilities, but also actively engaging digitally empowered end users. We will empower them to improve their access to and utilization of innovation and knowledge. And the second is by co-designing inclusive digital services. We want to facilitate the co-design of inclusive, transformative digital services across the entire food system, following demand and value-driven product development approaches and practicing, and by collaborating with private sector and development organizations. We want to develop cutting-edge and context-appropriate digital solutions. And third, most important, is the data accessibility and exchange. We commit in CJR within this 2030 strategy to improve access to and the utilization of data, information, and digital innovations by our partners. With a special focus on small-scale farmers, we want to actively seek new digital applications that accelerate learning and exchange among our stakeholders. Additionally, we're committed to adhere to the principles of FAIR: findability, accessibility, interoperability, and reusability of all CJR data. So as we navigate this dynamic landscape, the importance of open data cannot be really overstated. By making data fair, we empower both our scientists across CJR centers and partners in the Global South to collaborate, innovate, and drive impactful research outcomes. The accessibility and quality of data are fundamental in harnessing the power of AI or generative AI or other capabilities to tackle complex challenges in agriculture, food security, and climate resilience. But before we delve in that future and what it means and what CGIAR role could be in it, I wanted to share a story of a gift I received last week when I was at one of other centers, CIB, the International Center for Potato in Lima, Peru. And I was presented by this from the digital and data team there. So I don't know if you can look at it and if you know what it is. It's a mock-up or something. Anybody wants to take a guess other than the CIB people in the room? Any guess what this could be, what this is? I heard Kipo. Okay, so somebody knows what it is. We have a winner here. Yes, I never heard of it. So they left me actually for 2 minutes wondering what this gift is. I thought it could be a necklace. They knew I like jewelry. I thought it could be a headpiece. I couldn't figure out what it is. And then they told me the fascinating story of Kipo. And in ancient Peru, the Incas stored and analyzed complex information with knotted strings. So if you see, there's a lot of knots in those strings. And those strings with these knots are called quipos. And those devices made use of the knots' colors, direction, twists, complexity, and distance to record everything from census and agricultural data to astronomical observations. And remarkably, the quipos also employed a base 10 system and could represent numerical values, quantities, and even narrative information. So fast forward to present day, this was very inspiring, and I was like, this could not be more timely to prepare for the Dataverse. So for me, this was, you could think about it, this is maybe, Quipos was the, let's call it the Dataverse of the past. So fast forward to the present day, we find ourselves grappling with similar challenges around sharing data, making use of it, and collaborating around it. And we find ourselves in an era marked by unprecedented volumes of data as well. So with the exponential growth of digital and information, the effective management and sharing have become paramount. This is where Dataverse, I think, has emerged, in my opinion, as a beacon of light, as the Kipo of today. And just as the Inca civilization utilized those knots, yesterday I learned a new terms that improved my Dataverse vocabulary. I learned about the pits and the orchids and the roars. So I feel really I got a lot of vocabulary in addition to learning about the quipos last week. And I started really doing some analogy. I was like, oh, so the knots and the colors, they're kind of equivalent to the pits we have, which it helps you identify, have unique identifiers. It builds trust because there is trust in the craftsman of how you really construct those strings. But also the quipos had experts. They were called kamayunkona. And the equivalent of that today, if we think about it, today we go to the data scientists and we go to AI. So those were like the experts, I would say, of that era. So it's fascinating. We could really talk about that and the analogy forever. But I was fascinated about really that concept and importance of data sharing securely and what you do with it and the record keeping and the effective management that we have, which continues to be a need of today, and we continue to really rely on data in a lot of things. And I believe that when I was looking and learning from the presentation today and yesterday, I learned about really the remarkable adoption of Dataverse and how the usage has been soaring, and there has been some really transformative use cases, especially in the health sector and different fields, and how I learned how researchers, communities have been collaborating and sharing their findings effortlessly using the Dataverse and the standard way and the trust that is built in that community. And even within CGIAR, I learned even more about how much presence we have in Dataverse. And we witnessed also a growing trend towards leveraging platforms like Dataverse to enhance data sharing and collaboration. And I believe also that our network of the 3,000 partners, they have been also benefiting from this data that we make available in a platform like Dataverse. But as we gaze really towards the future, I think we must start considering the role of artificial intelligence, AI, and now generative AI, in shaping the landscape of data sharing. And I'm thrilled to see that there is a session going to be around AI and where we take Dataverse next with AI. So, but I wanted to, sorry. So I think, as many probably have been experimenting with AI and connecting it with the Dataverse data sets, I think AI holds really a promise of unlocking hidden patterns with data sets, and also enabling us to extract valuable insights and drive informed decision-making. And by leveraging open data through platforms like Dataverse, I think we can harness the power of AI to address pressing global challenges, especially for us in the agriculture field, and areas like climate change and food security and beyond. So while there might be a number of use cases in the making, I wanted to share kind of an imaginary, although I know a number of people in the room, they will say we're already doing this. But let's imagine a scenario with how open data resources in Dataverse could be potentially leveraged in an agriculture research use case of, let's say, building a model or training a model using AI. So imagine a research project at one of centers, let's say CIMMYT, we're here, aiming to develop a predictive model using machine learning to forecast crop yields based on environmental variables and farming practices, which is the core of a lot of strength that CGIAR has. So to train the model effectively, the research team needs, of course, access to diverse and comprehensive data sets of historical crop yield data, weather patterns, soil characteristics, agriculture management practices across different regions and crops. So in this scenario, the research team, let's say, will turn, assuming that all of this data is now in Dataverse, they will turn to Dataverse and try to really access variety of open data sets to agriculture, climate, environmental science. And they will discover multiple data sets in Dataverse containing anonymized crop yield data from past research studies, weather data from meteorological stations, soil composition data from soil surveys, and agronomic data from farming experimentations. And by integrating and pre-processing all of these data sets, they could come up with a training set for an AI model. And once this model, let's say, is trained, they could test it, they could keep fine-tuning it, validating it with more data that is going in the pipeline of Dataverse. And through that rigorous training and validation, we could actually develop and improve the predictive accuracy of such model. And the result will be a model that can be deployed to provide valuable insights to farmers, to policymakers, and agriculture stakeholders, helping them to make data-driven decisions to optimize the crop's production and resource utilization as well. So I know while this sound like a hypothetical scenario, as I mentioned, a number of our researchers here will say they're already doing that. But imagine if we have all of this data already in Dataverse and available and linked, plus, of course, not just the data that we have and we produce as CGIAR, but also data that is coming from, as I mentioned, weather, soil, experimentations, etc. In this way, I think that open data platforms like Dataverse becomes a valuable resource for agriculture research by enabling, of course, our researchers to access and utilize and leverage these diverse data sets to train the models. So that example is just a demonstration, and I don't think it's far from reality. I think it's very doable, and probably a big part of it is being done. The reason I mentioned this as a scenario to imagine the possibilities is because I feel as we look ahead, investing as a global network of CGIAR in platforms like Dataverse and expanding its reach to the global south and to our partners is not merely just an option, but I would consider it a very strategic imperative. And in other words, I want to say that it's actually a responsibility of CGIAR to really ensure that if CGIAR, the leading agriculture organization, is not the one ensuring that, similar to the health sector and how they leverage Dataverse and they made transformative application by linking this data, if CGIAR is not the one going to make sure that the agriculture data usage and development is there in a platform like Dataverse, who would be? So I think it's really our moral responsibility as CGIAR to lead that with partners like Dataverse. So in closing, I want to invite you to reflect on this enduring legacy of the KIPO systems and its profound connection to our present and future endeavors in data management and sharing. Just as the Incas harnessed the power of data to navigate complex landscapes and build sustainable societies, so too do we embark on a journey where open data serves as the cornerstone of progress and prosperity for generations to come. And just as the KIPO told stories of ancient civilizations, I think Dataverse and other data sharing platforms are writing the narrative of our digital and data age. With the integration of AI in the horizon, we stand at the precipice of a new era where data becomes the currency of change. Thank you for your commitment as a community to a future where data transcends boundaries, transforms lives, and paves the way for a more sustainable and equitable world. Thank you.
So we do have 5 minutes for some questions, if anyone would like to speak with Dr. O'Day. Just raise your hand.
I have a question. Thanks for the great talk. I have a question about ownership. So just imagine a situation when artificial intelligence will start to create data based on what it learned. And who is owner of data? How we should publish it? Yesterday we learned that, for example, ORCID is not possible to assign to AI. It should be human. Do you have some opinion about that?
Well, it could be personal opinion, but I would, as a technologist and somebody who's trying to really drive and accelerate innovation, I like to think of the possible before putting the obstacles. So I think while data ownership is definitely, and privacy and all of that are things that have to be thought about. But what maybe I like most about the Dataverse as a community is that it solves that issue because it gives, and especially with data that CGIAR brings. We mentioned we are a public good type of organization. We consider the data, the knowledge, the findings, we want this to be reached to the extent possible. So I'm sure ownership is going to be important, but there are already, I would say, solutions out there, practices, and a very solid community for open governance where we can recognize that the source, the provider of the data continues to be the owner. And that's why we emphasize FAIR, for example, as key principle for anything we want to do with data as CGIAR, because we want to, recognize the ownership. And also CGIAR is trusted with the germplasm and the gene banks by the countries that we serve. So this is one of the biggest comparative advantages CGIAR have, is we are trusted and entrusted with a number of assets like the germplasm, as well as the data that you extract from them. So it is important, but I don't think we should make it or start with the obstacle. I think we can find creative ways of solving and having proper governance and respect and of the ownership of the data, as long as we are serving a bigger purpose, which is to advance innovation and find solutions.
Thank you.
I think it's very inspiring for you, as you are the director of CGIAR data, and I don't know what your title. Do you have a kind of vision? What's your vision for CGIAR ag data? You know, this is very diversified. Your vision, another ag dataverse or something, you know, what is the, you know, maybe in the context of one CGIAR very form. You have any vision about, you know, kind of all diverse data together, get another ag maybe dataverse?
Sure. Well, as I mentioned, I have a very easy job, which is trying to develop and build a digital transformation strategy for CGIAR that really brings amazing 15 centers, visions, and strategy, and builds on great work that is already in the making. But the digital transformation strategy that I have been working on for the last 2 years since I joined is really anchored in the 2030 research strategy that I shared. And those are 3 elements of how we're going to make digital revolution central to the way of working is really the anchor for the digital transformation strategy. And that strategy has 3 pillars, I like to call them. One is really to ensure we have an enabling infrastructure for everything we want to do. If we want to do big data, analytics, all of that, we need solid infrastructure in place. And the second is, of course, to optimize a little bit our operation model. How can we really ease and make it seamless for our 15 centers to collaborate, to share data, to streamline so we are not wasting the time of our scientists or operations or management on administrative tasks. So that's another big pillar, I would say, of our digital transformation. But the third pillar is all about innovation acceleration. And that part is going to be achieved or envisioned now to be done through one of the CGIAR has part of its 2030 strategy, and the 3 action areas have, at the moment, more than almost 33 global initiatives that are cross-cutting. They tap into the scientists from all across the centers, and they deliver, of course, work in the 5 impact areas that I just shared. And part of now the next cycle, I would say, of our initiatives, we're doing a little bit more clustering around impact. And I'm really excited that the next cycle of our initiatives is going to include what we call the mega programs. And one of the mega programs is going to be around digital and data innovation as a cross-cutting enabler. Because we realized we cannot be fragmented. Every single science program, any area of the 3 action areas has a data and has a digital component. So my role, what I'm trying to do with the community of the IT teams and the knowledge management teams across the organization is really to advocate that we need to take a cohesive and strategic approach to digital and data enablement so we can really accelerate innovation, we can agree on standards, and we can ensure that we also build and develop inclusive digital and data solutions. So I think we made a lot of progress on what's the role of the global digital and data in driving that transformation strategy, and now charting or designing what we hope to become more of a, not just an initiative and a program for a couple of years, but we're hoping this becomes an institutional capacity that continues to support CGIAR in its 2030 strategy and beyond. So that's where we are at the moment. And I'll be around, so feel free to stop by and have conversations. Thank you again for having me here. Thanks.
Thank you.
Thank you. Thank you so much.
Yeah, that'll probably, that might be closer. We gotta introduce you.
Okay. Next, what? What'd you say? No. Oh, more will come in. Okay, so next we're going to hear from Philip Consett and Rory McNeil regarding the Dataverse and National Research Commons, the case for reason. You met Philip earlier today. He's the chair of the GDCC steering committee. He's also a senior research librarian at the UIT of the Arctic University of Norway and is repository manager for Dataverse NO and of the Tromsø Repository for Language and Linguistics. Rory McNeil is CEO of Research Space, which provides a connected electronic lab notebook used to capture, organize, and present research data. He's keenly interested in joined-up research data management infrastructure and in improving active data to archival data workflows and ELN to repository workflows in particular.
Okay, thank you for the introduction, Kevin. Yeah, let's just jump into it. So this is the outline of our talk. I'll give you a brief overview of Reason, a little bit about the background for the proposal, and then I'll briefly present the technical core of Reason and give you some ideas on how we envision to implement Reason. And then Rory will be talking mostly about the rationale, why build Reason, why use the GORC model. He will explain what it is, and also why the timing is right. And then at the end, he will ask the question if we could Reason and also the GORC model as a kind of reference model for other research commons. So this is a brief overview of Reason. It's a proposed generalist research infrastructure for Norway. It complements and supplements domain-specific and specialized infrastructures, and it includes the 9 essential elements of the new Global Open Research Commons model, or in short, the GORC model, which was published late last year by the Research Data Alliance. So the background, it originates in a national funding initiative that is organized or managed by the Research Council of Norway. They provide funding for infrastructures to establish infrastructure or upgrade infrastructure of national importance. And in 2020, we applied the first time to get some funding to upgrade Dataverse NO, the repository. The proposal was turned down, unfortunately. But last year, we then considered resubmitting the proposal, an enhanced version of the proposal, but we got some feedback from project partner institutions, and also an external consultant who told us that probably this kind of proposal will never make it, so we had to come up with a kind of more ambitious project, and that's where Rory pitched the idea of a research commons. Yeah, so as I said, the research commons for Norway will exist, or is envisioned to consist of the 9 elements of the GORC model, and the most prominent of these elements is the services and tools element, which is the one the users will be interacting with, and that enables end-user functionalities. And basically, it will connect things across the research lifecycle, and more specifically, it will bring together research objects, for example, DMPs, data, publications, with cloud computing infrastructure and software, services and applications for managing, analyzing, and sharing research objects. And we tried to roughly sketch what this technical core could look like, and you see it on the next slide. So you see here the different phases or stages in the research life cycle, from planning and preparing to collecting, processing, to sharing and reusing and publishing. And you also see a kind of layered approach here, where you have the storage and computing layer at the bottom, and then you have this kind of layer with the user interaction, and you also have a distribution and harvesting layer. And you can see there are different tools that are at the core of this envisioned Reason infrastructure. But at the heart of it is Dataverse NO as a trusted digital repository, a national one, which is at the heart of this services and tools elements. And we envision the plan is kind of built on extensive and continuously growing support that the Dataverse software has for integration with other tools across the research life cycle. here you see briefly how we envision to implement this, a list of the work packages. I don't have the time to go into this, but basically the main point here is that together these work packages will establish the 9 reason elements. And also Dataverse NO is at the core of the governance and engagement elements of reason. And here we plan to build on the extensive collaboration we have already across the Dataverse NO partner institutions. In this consortium we already collaborate on data curation, of course, within the Dataverse NO repository, but also in other areas like DMP support, RDM training, and also computing and storage, and other services and activities. This brings me also to the partner organizations, the project partner organizations, who consist of together 14 organizations. 5 of them are national partners, all of them within the Dataverse NO consortium. And then we have 9 international partners, and all of them are either using Dataverse or collaborating with Dataverse or data institutions, organizations that use Dataverse, and I think almost all of them are represented here at the community meeting. And we also included some cascading or integration grants into the proposal, mainly aimed at other institutions in Norway that are not part of the project consortium, but also services and tools providers. So this is, in a Norwegian context, this is kind of an innovative funding tool, which has never been used so far, but it's quite common in European grant proposals and projects.
Thanks, Philip. Hi, everyone. So normally maybe you'd expect us to give the why we did this first and then tell you what it is, but we thought it'd be a lot more digestible if Philip told you what it is first, and then I took a step back and said, well, why did we do this? So here we go. So why build reason? And this was really kind of the pitch we gave, if you will, to the Norwegian funding body. Why build reason? Why should you give us the money to build reason? So first, Research Commons have rapidly come on the scene, and they're now seen as the best internationally recognized model for delivery of integrated research services. They're being designed around the world, and not only at the national level, but also at the multinational level. For example, the EU DAT collaborative data infrastructure, I would say, is an example of a Research Commons, although it doesn't call itself one. And plenty of universities are thinking about doing the same thing. Stefano and I were at the MOC Alliance workshop last week in Boston, and someone from Harvard gave a presentation about how they're building what they call a data commons, but basically a Research Commons. So those are just a few examples. So also, and this is important as well, because no Research Commons is going to exist in a vacuum. So it was really, in designing this, it was important that Reason was able to bring together and enrich existing, perhaps insufficiently or unconnected research infrastructure components in Norway in this case, including domain-specific components. And clearly, there's a lot of domain-specific infrastructure out there, and if you want to be useful, you've got to figure out how you're going to interact with the existing and the developing domain infrastructure. And finally, and this is our pitch to the Norwegian funding body, by doing this, the first one, Reason will establish Norway as a global innovator in the provision of research infrastructure. So that's why build Reason. So why is the timing right? Well, the availability of the GORC model, which coincided with, I don't know if it was good or bad timing, but bad timing, I would say, for Philip. The model was published, I think, in late October, and the deadline for submission was the 15th of November, and I don't believe that Philip slept for more than maybe 28 minutes a day for those 3 weeks. So maybe he wouldn't say it was good timing, but on the other hand, it gave us a model. You need a model to work with. So the timing is also right because Dataverse NO, RSpace for active data management, iRODS for policy-based data management plans, and Diamond open access publishing services already existed. They combined to provide most of the essential technical elements needed in a Research Commons, so they're available. Again, Dataverse is already integrated. Dataverse is really the core, but it's integrated with other tools as well, including RSpace and iRODS. and both of which were and are enthusiastic participants in the proposal. Also important, the Norwegian research organizations involved in providing Dataverse NO collectively, and they were active, as Philip said, active participants as well. They possess an understanding of the research infrastructure in Norway, so the local context is really important. And also, again critically, they collectively possess relationships with organizations involved in providing the research infrastructure needed to progress and develop reason. And finally, and certainly last but certainly not least, if you look at the list of collaborators, partners that Philip put up, it's really a impressive broad range of expertise, experience, and connections is brought to bear by the other participants, including international universities like Harvard and KU Leuven, service and core tool providers like Dansk Data Sites and PKP, and all of them are already collaborating with Dataverse NO, so the relationships are there to help make this happen as well. Okay, well, I think it's not the most interesting part of all of it, but for me, this is the most interesting question. You know, to what extent can reason or should reason be a model or reference for others? Because this is really a hot topic, these research commons. So I think it's got quite a few things going for it. First of all, again, you won't remember the details, but the 9 elements of the GORC model, all of which are fully documented as to what you need to have, all of them are part of this proposal. So it comprehensively uses the GORC elements. Second, as you can see from that map, a graphic which Philip put up, there's a detailed instantiation of the service and tools element, which is the core element of the GORC model. Of course, all the commons are not going to use exactly the same tools and services, but what we're saying is, well, look, we're not just walking the walk, we're not just talking the talk, we're walking the walk. This is what it could look like, and here are some actual tools and services. Third, it's built around several tools with complementary general usefulness, tools like RSpace and Dataverse, that are designed from scratch to enhance verification of data. Fourth, there's a strong focus on interoperability of tools, data, and metadata, which is crucial to what we want to achieve. Fifth, we explicitly acknowledge the need to interoperate with existing generalist and domain-specific research infrastructure that was relevant in the Norwegian environment. Sixth, it combines the support of multiple Norwegian universities and national infrastructure providers with involvement of international technology and university partners. Of course, in different contexts, the actual players would be different, but the notion of having this mix of players seems highly relevant. And finally, the last one is very Norway specific, but we said reason could play a role in a future national EOSC mode in Norway. But again, EOSC nodes are being now considered or piloted around Europe. And in fact, there are some examples which I'll mention of EOSC nodes which are also thinking about developing research commons. And in fact, things are happening really quickly. Last week, I think it was last week, no, 2 weeks ago, Philip and I participated in a session from the Global Open Research Common Working Group at the RDA, and the GORC model is already stimulating interest. So SURF in the Netherlands is thinking about it. The Helmholtz Association is thinking about it in the German context. The Digital Research Alliance of Canada was one of the drivers behind the development of the model. They're thinking about it. An interesting Elixir is now thinking about it, again, in this case, in a domain-specific context, not a national context. And we're really excited because not only is GORC eliciting interest, but Reason is already eliciting interest. So Biofair, which is a major new project in the UK, which usually doesn't go in for national research infrastructure, this is the first and possibly the only one. The Elixir node in the UK has a grant of £35 million or so from the UK government to actually build a research commons. It's going to be called Biofair, built around Elixir stuff. And we had a call with them. They are extremely interested in using Reason as a model for what they're doing, and we're continuing to engage with them. And then just last week in Boston, the New England Research Cloud, which is not a research commons, it's a cloud built with open technology intended to kind of be an alternative to AWS and Google and Azure for the academic community, which is heavily computationalist in its kind of ethos. They are now very interested in Reason as a model, and I'll talk a little bit more. But if you look at NERC, it's actually not dissimilar to the again, the graphic that if you look at the green part there, where it says MGHPCC, is a huge data center which Harvard, Northeastern, BU, UMass, and MIT have put up. And on top of that sits this open cloud. And on top of that, they want to build something called the New England Research Cloud. But what's the New England Research Cloud? Well, it could become a data commons, research commons. So if you look at where it says cloud services and technology adoption, you can imagine a layer of SaaS applications which interoperate together, which become a research commons. This is not my slide, this is the NERC slide. And this is really exciting because at the MOC Alliance workshop last week in Boston, this was the slide that they put up, the NERC put up in their summary of the 2 days. And you can see they've already incorporated, again, notionally, Dataverse and RSpace as core elements, foundational elements, they call them, of what they see the NERC becoming. So that's their slide. And here, this is just a version of the earlier slide which Philip put up, or if you look at the bottom where we have this, the Massachusetts, the New England stuff, the MGH, PCC, NESI, and NERC. Again, it was that was in the case of reason we had the Norwegian elements, and that was my last slide. So thank you very much.
There'll be time for Q&A after this session is done anyway. At the end of all the speakers, we'll have a panel.
Okay, everyone. Next up, we're going to speak with Cees Hoff. He will tell us about a data station for the life sciences, reaching out to the Dutch life science community with Dataverse-based repository services. Cees is the data station manager for the Data Archiving and Network Services, or DANS, which is the National Data Institute for the Royal Netherlands Academy of Arts and Sciences. DANS holds several Dataverse repositories for different scientific communities, and Cees' responsibility is in the interaction with the life sciences and the management of DANS Data Station Life Sciences. Through this data station, they serve researchers in health, medical, and also the green life sciences, focusing on the Netherlands. In addition to Cees' work in this capacity, he also trains scientists and data stewards on proper research data management.
Thank you so much for introducing me. I'm really, it's really great to stand here. I'm new to the community. I'm also talking about something new to establish, so I feel slightly uncomfortable being in the same session as the keynote, and my predecessor was the community, Philip was the community guru announced this morning, so, but I hope I can match up to the expectations in that sense. Yeah, okay. We had a discussion at DANS. There is a Dataverse meeting amongst other data station managers, and who will go there? And it was a bit of a, well, I mean, I'm not the most experienced Dataverse guy, but I'm a biologist, and I come from the GBIF community. And I had very good experiences with data in Mexico. I don't know if Conabio rings a bell here, but it's a really an example of how today to deal with biodiversity data at the national level. And Conabio from Mexico is one of the leading institutes when it comes to biodiversity data. So really good experiences. And also from the opening we had this morning from the director, I see there are more very interesting biodiversity related institutes and initiatives in Mexico going very strong. My name's actually Kees. It's always a difficult thing with the Dutch names, but no. I can tell a whole story on this. No. No, actually, Cees is grammatically speaking correct. But I'm representing DANS. DANS stands for Data Archiving and Network Services. We are an institute of the Royal Academy of Arts and Sciences in the Netherlands. We are strictly working on research data. No research, only on data. We are the National Expert Center for Research Data, and also we provide repository services. Our three major pillars are expertise on research data management and data, We provide repository services, several repository services, and we are a very active collaborator in national and European projects related to data and data infrastructures. The history of DANS goes way back to the 60s, so a lot of experience on dealing with digital research data. We received different names in history. Since 2005, it's DANS. I have to say the history goes back to the 60s, but always concerned social science and humanities data. It's only since recently that we are also reaching out to different disciplines. 50 years of experience of dealing with digital research data. A little bit, a short timeline on our repository history. For quite a while we have been running EASY. It was a self-made electronic archiving system, quite successful in the Netherlands and an example for many other repositories, especially in Europe. In 2013 we started to embark on the Dataverse adventure by establishing Dataverse NL. It's now celebrating its 10th year, very successful. It's set up as a collective service, so it's owned by several institutes, including DANS, and DANS is providing the technical support and also the administrative and financial support for the consortium. So there are many institutes using their own Dataverse repository in this structure. EASY was getting old, and we moved to another system that we called the data stations, the DANS data stations. Only recently, the last data station was launched in December 2023, and EASY has now been decommissioned. It's still online, you can actually search for data, but it's not possible to use it as a repository anymore. Why did we move over to those data stations? And if you really want to know the details, there is also a poster on the data stations, and I can get much more into the details of the setup of the data stations and the central data vault. But for now, I think it's good to mention that we are a national repository. We want to serve all disciplines in science. We don't want to exclude any kind of discipline. But we also want to provide more domain-specific services. Our experience with a generic repository like our previous EASY is that if people want to interact with a certain domain platform or want to use domain-specific metadata, that's much more complicated. So therefore we decided to follow the major branches of science that's used by the major scientific funding organizations in the Netherlands, and we established these disciplinary data stations. It allows us to better interact with communities, to better interact with domain-specific platforms and catalogs. And an important feature is also that there is a person in between. So the data station manager it's a real person between the community and our technical services. Our duty is to translate the needs of the community towards our technical repository services. Bear in mind that a data station is more than just a Dataverse. It includes training, it includes documentation, it includes certain events, so it's much more than just technical installation. And concerning the different disciplines, here you see the 4 data stations that we established: social sciences and humanities, life sciences and physical and technical sciences, and 1 for archaeology. Of course, archaeology is actually part of the social sciences and humanities, but we have a very long history with the archaeological community and a very large amount of data from archaeology. I've provided the figures underneath the data stations, and there you see it's not a very equally balanced distribution. Social sciences and humanities, I would say that's the kind of on average. Archaeology is really peaking. And there you see that the life sciences and the physical and technical sciences are really underrepresented. And why this exactly is, it's partly because we didn't approach those communities, but we also, at this point, we don't exactly know where all these data are at the moment. So, and if you compare it to the research output in the Netherlands, and one of our sister institutes within the academy, the Rathenau Institute, is monitoring scientific output. If you look at the publications, for example, in the period from 2017 to 2020, almost 40% of the output in terms of publications is from the health sciences. But where are all these data? We don't actually know. Of course, we need to figure out and we need to get in touch with this community, but it also proves that I think there are definitely opportunities here and that we should seize these opportunities. I'm focusing on the life sciences. Here you see our life science data station. So what's the situation at the moment? Basically carte blanche. It's a generic Dataverse. There are no domain-specific adaptations at this point, around 1,000 data sets. Lots of expectations because we started to spread the world a year ago. And a nice icon for the data station, so that's at least something to start with. And now I've developed a strategy on how to go on and how to reach out to the life science community. One of the first choices was to decide not to say, well, we are for the life science, but to indicate kind of subdomains and hence sub-communities for the life sciences. That decision was based on the subdivisions that our major funding organizations use. And we came up with a data station that's actually focusing on the green life sciences, the medical life sciences, and the health life sciences. And there you see the disciplines below. So green is obviously ecology, biodiversity, or living environment. Medical is basically hospital-based research. And for health, we are reaching out to the more like population research concerning our mental or physical well-being. Another choice we made amongst the life sciences, of course, there are incredible large data sets around, whether it's bioimaging, all the omics databases, the genetics databases, long-term cohort studies on health and well-being, and that's obviously not the community we are approaching. We decided to go for initially the long tail of science. So the smaller data sets from individual researchers or small research groups, data sets that are being created with a lot of energy and knowledge and inside knowledge, but are not always so easy to find and to use, and very often at all different places. But that's our primary focus. We have experience with the long tail of science. You see a poster on a workshop that we organized for the long tail of science in bird research. And other issues, and they've passed at this meeting already, of course, are things like promoting open data, fair data, and reproducible research. We are lucky to quite easily pinpoint the specific communities of interest to this new data station. For the green life sciences, there are two very large initiatives in the Netherlands, and that means like 5 to 10 year long research programs based on like 40, 20 million euro projects. One on mapping all the multicellular species in the Netherlands, so well, it's quite a lot of data, of course, but another one is Alter Life, an Alter Life long-term ecological research project, and that focuses on creating digital twins of ecosystems, especially based on legacy data, and that's a place where we very well fit into. Concerning the medical community, a very easy and, well, I wouldn't say easy, but a very good target would be the smaller hospitals. They usually don't have, they have a technical department, but that's only taking care of their internal ICT infrastructure and things like patient data, but not so much on data publishing, data sharing. There are quite a lot of these hospitals in the land, 27 altogether, working in a collaboration, high-profile research, small but high-profile research, and we already got in touch with them, and they're definitely interested in using a Dataverse environment. Concerning the health sciences, the Netherlands is one of the leading countries when it comes to health research. We have a very large research infrastructure for health data. It's called HealthRI. I think it's an 80 million euro project. Obviously, we are not going to tackle the health community without cooperating with these kind of organizations. And this goes quite well. It's very easy for them to have a data partner on board that deals with the smaller data set. So there's another very nice opportunity for collaboration. Without money, we won't realize anything. So before the data station was actually launched, we already tried to get involved in projects. We are participating in L2 Live, the project that's creating digital twins of ecosystems in the Netherlands, and where there we have a very specific role of hosting the legacy data and mobilizing those data, verification of those data, and at the end even creating a catalog. Another project that we are involved in is a European project around health data. It's called Quantum. Only 2 weeks ago, the kickoff meeting was actually performed. It's a project that provides quality labels to health data within the scope of the establishment of the European health data space. And we are a small pilot in this project using Dataverse and see whether we can match with these quality labels into we can merge these quality labels into our Dataverse environment. Starting with the green life sciences, of course, I have a wish list, and I discussed this with also, to a certain extent, already within the life science Dataverse community. Obviously, a metadata block for ecological and biodiversity research is something on my list. Connection to species names. If you're a biologist, species names or life scientist species names are important, and it's not something to be neglected easily. Proper names, connecting your data or adding proper species name to your database is a very important feature. Not that easy, but it's definitely high on our list. And getting more into the details, for example, Darwin Core Archives file, that's a data format coming from the biodiversity community, is something I think we can quite easily integrate in the Dataverse data station that we have currently. Here you see an example of how this works. I won't get into the details of Darwin Core Archives, but I've worked with these systems in my previous job, and I think it's quite easy to integrate this into a Dataverse environment. And that would really be a very strong combination. If you can use a basic Dataverse installment to publish your data within the biodiversity data community, it means they will automatically end up in the GBIF portal. It simply means publishing your data or putting your data in one place. They will be exposed in many different ways. I absolutely do hope to take this on board, and I'm also willing to take this initiative within the community. As I say, I don't think it's very difficult technically wise. It's more like understanding how it works and providing the proper instructions. And for me, it's also a very important theme. Within our data station, we are really eager to mobilize data from the long tail of science into big science. And I think, for example, the GBIF network is a very nice example. If you do your little research on butterfly distribution in the city, you publish your data in this proper way, they will become part of this big science effort around biodiversity data at a global level. As I mentioned, the connection of species names is very important, but also quite tricky. Several attempts have been made. It's not always that easy. Not everybody is using the same naming catalog. Here I just simply demonstrated some potential candidates to connect to our Dataverse environment. The Catalog of Life, that's a global standardized species list with proper web services. We have the Dutch species register. Now, obviously, for us a Dutch, serving the Dutch community, that's another trial we're going to embark on. It will also be possible to move into more like subdiscipline-specific cataloging, name cataloging system like WORMS. WORMS is a World Register of Marine Species. It's very, very technologically well advanced, so it could be a perfect source for standardized species name from the marine research community. And I think Slava is even going to tell a little bit more on these kind of ontologies as he's currently working on OntoPortal and AcroPortal that includes elements of species names. As I say, metadata, of course, important. We are currently investigating whether EML, ecological metadata language, would be something to include and integrate in our metadata profile within the data station. I have to say I'm not entirely convinced at this point whether it's really adding so much more value next to what we already use, simple doubling core standards or data site standards. I actually do speak with other life science repositories like Dryads. I was a couple of years ago, I was quite impressed by the way they integrated species name in their system. And when I recently had a look, I noticed there were no more species names in their system. And so I got in touch, and why? Well, you know, in the end it appeared that only 1% of the depositors actually use the species names. And I don't think that's it's a fault of the depositors. To me, it means you can create a technical facility, but if you don't promote it and then don't stimulate people to use it, it won't happen. So I think that would be a good lesson for us also. Jumping to another interesting issue, talking about metadata blocks within your Dataverse environment. The larger medical institutes in the Netherlands are actually not using our data station. They're too big. They have their own ICT departments. They actually are using Dataverse. So they want to stay in control of their data. If you're using Dataverse NL, you yourself are managing your data, and you yourself are responsible for the data. If you put the data, your data at our data station, we are the custodians. That's something the hospitals usually don't want. They want to manage their own data. But now within Dataverse NL, they are creating their own metadata block for medical data. And if they indeed establish this metadata block, how convenient for our data station, because we can simply copy this and use it for other medical data. So you see, it's a very strong combination. If you have on one side your Dataverse that's being controlled by us as an institute, we are the custodians, next to Dataverse installments that are being developed by the users themselves. And my last slide, there are some challenges ahead of us. As I just mentioned, Health RI is a real large infrastructure around health data in the Netherlands. They have been very creative setting up their own metadata catalog based on DCAT, a very nice visualization. It's actually the sunflower model, they call it. There are the core metadata and a lot of additional, more domain-specific metadata. We're currently investigating how we can actually map our metadata easily to their metadata. And obviously, when working with the life sciences, sensitive data is a real difficult issue. I will definitely join the sensitive data session later on in this meeting. And the good thing about our data stations that, of course, sensitive data, that's not only an issue in the life sciences, but it's also an issue in the social sciences. So together with my colleagues in the social sciences, and actually they are slightly more advanced at the moment, when it comes to dealing with sensitive data, we collectively can work on these issues. And I think I passed my 20 minutes, and I want to thank you for having me over here, and I'm really looking forward to collaborate more with you all in the future. No.
All right, next we're going to hear about the internationalization of Borealis, which is the Canadian Dataverse repository, from Jonathan Dory. Apologies in advance for my poor French pronunciation. Jonathan Dory is a research data management advisor working for Institut National de Recherche Scientifique, École Nationale d'Administration Publique, and Université Télic in Quebec, Canada. He is also part of the Borealis Canadian Data Repository team, and there he works on translation, internationalization, and French services. He's also a member of a number of working groups, including the Digital Research Alliance's Data Management Planning Expert Group.
So, good afternoon, everyone. Bon après-midi, buenas tardes. If and when you see the slides that I'm projecting, which I believe you might actually see the notes, I've provided a French and Spanish translation under. I will loop back towards the end in the process that I use at Borealis for translation. The French is fine. I'm a translator, native speaker of French, so I'm pretty confident. The Spanish has been run through Google Translate. I've run it multiple ways to make sure that it's sensical. Hopefully it is. If it's not, I apologize. But today we will talk about what is Borealis. I will talk about the Canadian customization of Borealis, or the Canadian Dataverse repository. I'll talk about the Canadian-French internationalization and specific issues related to gender-neutral metadata and interface. And I'll finish about community engagement. So what is Borealis? Borealis started off, as you might know it, the Scholars Portal Dataverse. Scholars Portal is based at the University of Toronto in Canada, originally an organization that served universities in Ontario. The name change to Borealis was meant to reflect a more national repository and scope. So something that wasn't only tied to Scholars Portal or Ontario. So Borealis currently runs on version 5.13. We will be upgrading to, now we don't know, version 6.1, 6.11, 6.2, we don't know yet, but it is scheduled for March, so we'll have to see what happens, but we are currently at the latest version. All the data and the files are stored on the OLRC, the Ontario Library Research Cloud, which duplicates nodes across Ontario for good safekeeping. It integrates multiple aspects of Shibboleth for single sign-on, for institutions that use that service, and also all the contents is indexed in DataSite search, in Google Dataset search, in Lunaris, which is a Canadian discoverability tool, and other places like OpenAir through Further and Lunaris and other platforms. In terms of metrics, because we do like numbers, we currently have, at the time of making the slides, we had 70 institutions. Now we're up to 71 institutions. One university just joined last week. There is a consortium of 40 colleges that have joined, so they are considered one institution, but they really represent 48 different colleges, all in Quebec. So it's primarily universities that are part of the service, but we are also seeing an uptake in colleges, which are defined differently in each of the provinces in Canada. We are also working with university research centers, different institutes, to bring them on either as full members or as affiliated members. We have over 20,000 published data sets in Borealis. That accounts for over 370,000 uploaded files. And since Borealis, or at the time Scholars Portal Dataverse started, we have now reached over 17 million downloads of individual files. So it is getting used. I don't have a graph that shows the increase, but it has increased steadily over the last year. There's a number of customizations that were done to the core code of Dataverse, primarily so that it would work in a Canadian context. Education and research tends to work more at the provincial level. There is funding federally, but we do have to account for that. The name of institutions is going to be slightly different, and the ways in which an institution is considered an education institute is also slightly different. So the internationalization of the code started in 2016. The OLRC storage needed to be configured at the time, so all those customizations have been done. Single sign-on works through the Shibboleth, but also through the Canadian Access Federation. So some institutions have it, some institutions don't. Some institutions use the Federation for Eduroam, but not the single sign-on, so these were all had to be accounted for. We also have different custom affiliations. The Borealis team, prior to me joining, were working on the data curation and the data explorer tools, which are now part of the core code. There's various metrics reporting tools that have been developed over the years. And there is a project right now working on the Globus integration, which you're going to hear more in the coming days. We're going to skip very quickly over these phases, but the French-Canadian internationalization started in the early 2010s, in 2016. This is at a time where some institutions in Ontario were interested in having French services, the University of Ottawa in particular. It's based in Ontario, but it is a bilingual university. It's not the only one. And there was a discussion to make the platform more national in scope. Therefore, universities in Quebec that mostly operate in French wanted to have a platform in French. So the work was done in Canada, but also with help from a number of contributors. I'll mention some of them later. And it went into various phases, a prototyping phase, phase 1, phase 2, phase 3. I'll skip the details. Needless to say that nowadays the platform runs fully bilingually. The interface works in French and English. Now, I do apologize, these are the PDFs, so you won't see the details, but it looks like Dataverse, basically. And the names of fields, the search features, the functions, all the wrapping that you would see is going to appear in French. The contents of collections and data sets will appear in the language in which it was created. Some institutions will provide bilingual descriptions, some won't. Some French institutions will provide English descriptions. Some English institutions will provide French descriptions, depending on what field it's in. A professor in French literature at the University of Toronto would probably describe the data set in French or other languages. The Canadian French internationalization was started off with a bunch of people. It was an internationalization project to internationalize the code. On top of that, there was the French translation. Again, this was done before I joined, although I did work a little bit peripherally on some of the early work. The code was developed at first very much in sync with what was done in France and Europe. Over the years, because of the various change in people and turnover, those links unfortunately got not severed, they just disappeared. And we are currently trying to rebuild these. So the translations that we are currently providing in Canada is very much focused on a Canadian context. But I am hopefully going to have time, energy, and effort to put into doing a full audit of what are the differences between the French-Canadian and the French versions of Dataverse, and hopefully try to come up with some common version. For one thing, it would help both of us not have to duplicate the same work. Also, we have a lot of collaborations between those two countries or regions, and the same goes with the English version in Dataverse, although I believe there's only one version. There isn't a British or a Canadian version. The contents of the Canadian version is very lightweight in terms of differences. Translation process is a very straightforward process. We take the code from GDCC in English. We run the comparison tool in GitHub, so we see what's new, what was removed. I do the translation using existing terminology, so we have that data bank. And also having worked on it, I know what is the proper terminology to use. Those changes are done in the actual property files, which I open in VS Code, Visual Studio Code. Make the changes. If there's add-ons, I add them. If there's removals, I remove them. If things were moved around, I do the same. And we re-upload the French version to the GDCC language pack so that those files can be deployed. Pretty straightforward process. I'm not going to talk too much about AI. However, Google Translate and DeepL both run on AI. They have gotten incredibly more performing over the years. My first degree in my first career was as a translator. I'm still a translator, and I still use those tools. And people always gasp when you hear a professional translator. We don't want to type all these words. We just pre-translate it through Google Translate. In a previous life, it would have been someone that did a first pass and someone more experienced would fix it. So I do the same. So AI is part of this work. There are probably ways to automate this a lot better. Google Docs has, if you didn't know, Google Docs, if you are in Google Docs native format, you can translate or pre-translate a document into another language and someone else can come and fix it. I like to call it fixing it. AI is a tool. Like any tool, it's good in the hands of people that are good and have good intentions and well-meaning. And it's not a good tool if you don't. So I use that to make my life easier and to basically churn out these translations a bit quicker. VS Code looks like this. I mean, it's pretty much I have nothing to say about this one. In terms of gender neutrality for metadata and the interface, so in the interface, there are metadata fields that have been described in a certain way. You may not, I don't want to say care too much about it, but it's not that relevant in an English context when you have something like author. In most other Romance languages, all words are gendered, so there's grammatical gender and the gender of like people to whom the words relate to. So in the case of author, you have two ways to translate it, feminine and masculine, based on if the person is a man or a woman. So to avoid all these things, we have gone away from using gendered nouns and referred to the action that was being described. So in the case of author, we talk about authorship, so it's auteur in French. Instead of talking about an administrator of a collection, we talk about an account with administration privileges or author roles or however else we want to word it. And we do this for two reasons. One, to avoid the problem of duplicating these terms and making the platform, it's not too bad in a platform with metadata fields, but in a text, it becomes quite cumbersome to always use two words or two versions of the same word. I'm not too much of a proponent of using periods and dashes because it makes it a bit more difficult for accessibility. If you're using a screen reader tool, these combinations, these typographical combinations make it a bit weirder for the tool to work properly. And there are ways to make it gender neutral, some other way. This is one way, it's not the only way. I know that in Spanish, for example, instead of talking about Latino, Latina, you talk about Latinx. That is something that that community has chosen, not so much something we see much in French. Talking about some of the messages, for example, files uploaded by the researcher. Do we really care if it's the researcher that uploads the file, or do we really care about the fact that the files have been uploaded? So that would become uploaded files will be in a collection or will be in a data set. So just slight changes in how we word things, particularly in the documentation. In addition to all of that, we have a lot of community engagement. There's a governance model. Again, I do apologize for the very small size of this graph. It is a fairly decentralized governance model. We have the Borealis team that takes care of the infrastructure. There is a governance committee that oversees the platform with representatives from the 4 regional university library consortia in Canada. All the curation and the help is done locally. So every institution has someone who is tasked with helping their local community, their researcher community, with curation, with data deposits, with making sure that the data was prepared properly and described according to fair practices. We have monthly meetings with the community of RDM specialists or Borealis administrators. And in these meetings, we talk about various issues, the new features and the various updates, common practices for curation, different ways of approaching preservation, and so on. These meetings are also governed by the facilitation team, so it's some representative of the Borealis team, in addition with someone from the Digital Research Alliance of Canada, which has an expert group devoted to Dataverse. So the Dataverse North chair also sits on this committee, and we have a curation specialist from the Alliance also sitting and helping to facilitate this community. As you can imagine, with the community of 70 institutions, we are now having a lot of people attending these meetings. So a meeting that started off with 18 representatives, now 70, the dynamic is a bit different as well. People are a bit more shy to ask questions. This was always done virtually on Zoom, which in a country the size of Canada, which has 5 time zones, is sometimes challenging, which requires 6 hours flight to go from one end to the other, or more actually. 6 is from Montreal to Vancouver. So we do things virtually, and we have done even before the pandemic. All the monthly meetings are done in French and English now, with my help and also the help of everyone else on that committee. So the meetings are held in French, people that can ask questions in either French or English, and there's going to be people that can translate and support the community. We have heard this morning about a survey of Dataverse. We have also conducted, and this was the work of my colleague Megan Goodchild, who was originally going to be at the conference and couldn't make it. So she and a colleague at McGill University, Lisa Rod, conducted a survey of Dataverse administrators in Canada, both at the institutional level and also of the people who are tasked to be the administrators. This work was done for the goal of developing an understanding of the community of administrators, but also collect information to help support the community. This was 2 versions of the survey, one institutional, one individual, with quantitative and qualitative data. If you are interested, you can go into Borealis and look up the institutional survey data set. If you don't have access to the slides, you can email me. I can email them to you. The data sets were put into Borealis. Very meta, I know. And the preliminary report is published in OSF space. So they actually went open science, so as good practice. The key insights from that survey is that our community is diverse, as you can imagine. So we have institutions of varying size and very delocalized. Some are fully virtual, some are completely almost on-campus education. Universities like University of Toronto, which has something like 72,000 students. I can't remember how many they have, and countless thousands of faculty members. And we have university, the university that I'm in is 700 students with 150 faculty members. So the size of these institutions is quite different. So the community is different. So there's a range of experiences and challenges. At my institution, I'm the one that does everything related to RDM. At other institutions, they can actually specialize in certain roles. The results indicate also that there are many commonalities. As you would imagine, we operate in the same environment, the same funding structure, and a lot of that can be solved collaboratively, which we are already doing quite a bit of. Curation is another example where we could do more as a community. Results also can assist us to benchmark the services, what we want to work on, what works, what doesn't work, where we want to be in the future, and also further the community engagement to develop recommendations and consider initiatives to address barriers and challenges collaboratively. In terms of next steps, and this, I'm almost at the end, so I would like to do a full audit of gender-neutral terminology. It's pretty much done in the metadata fields. There's still going to be some error messages that display, or forget the actual name of it, but the tips that appear in some fields that is gendered, so we want to fix that. We're going to review the terminology. That is my own personal pet peeve as someone who's trained as a translator, and I'm pretty picky about typology. The word Dataverse has 3 possible meanings in the platform right now, both as the software, a collection, and the name of the platform, which drives me insane. I am on record for saying this, which is also part of the way why we try to use Borealis as much as possible, and we only talk about collections, not Dataverse collections. So if anyone wants this work done, just email me and I'll do it for you. It's part of my work. Also, translation of the metrics reporting, which currently is only available in English, probably would require a little bit of internationalization and therefore could be done in other languages, and assess the differences between, like I've mentioned before, the version of French in France and the version of French in Canada, to bring those two together as close as possible. One example, the word data set was translated in 2 possible ways in French. Borealis or Dataverse uses one. Lunaris and Further, another platform in Canada, use the other, which is typically the same that is being used in France. So we're going to try to fix these up. I've also mentioned 2 things that are not there. One, language labeling of individual fields, so that we know that if you write a description that that field is in French, versus having that language tag over the whole data set. Same for keywords. That would be an interesting development. And another one, which is more related to indigenous rights, I've tested the platform for language-specific descriptions in Inuktitut, and in that script, the platform does support it. I haven't tested all of them, but because it does support multiple scripts, the platform could be used to support indigenous access to data and indigenous sovereignty of data. And if you combine that with different permissions and restrictions of access, you can actually use this platform quite nicely to help address that issue. The same goes with any other languages. Like I said, Canada operates primarily in French and English, but we have data sets in multiple languages. I will stop here and take questions with the other 2 presenters. Thank you.
Okay, folks, we're going to pause here for a 10-minute break, coffee break. Please go out, grab your coffee, and be back in 10 minutes. We can get started. Right. All right. Okay, everyone, we're getting started for the afternoon's program here. Next, we're going to hear about World Fair, CDIF, and cross-domain fair resources. Dataverse as a fairer repository. Aravind Gregory is going to tell us about this. He is a metadata standards expert with a background in technology, focusing on statistics and research data. He's contributed to the development of the Statistical Data and Metadata Exchange Standards, the Data Documentation Initiative, or DDI standards, the Generic Statistical Information Model, GSIM, the DataCube vocabulary, and he has also implemented and helped to develop many other standards and specifications in this domain. His technical knowledge covers XML and related technologies, UML modeling, SQL and RDF, as well as a range of programming languages. Currently, he is chair of the DDI Cross-Domain Integration Working Group and is involved with CoData's Decadal program, the World Fair Project. He's also an active member of the DDI Training Working Group and was an organizer of the IUSSP CoData Fair Vocabularies Working Group. Please welcome him.
Wow, next time remind me to make that shorter. That was way too long, the intro. So I'm going to talk today a little bit as, I guess, a kind of an outsider here, because this is not really about Dataverse directly, at least the first part of it. I want to talk more about FAIR and what's going on in the FAIR world. At CoData, we work a lot with RDA, with FAIR Impact, EOSC, GoFair, and there's a lot of activity in that space right now that I think will impact this community. And I say that with some confidence after seeing the presentations just recently. One starting comment about FAIR. FAIR, on one level, has been an amazing success. It was produced by academics, and 10 years on, everyone is talking about it and thinking about it. But I'm an implementer, not an academic. And so when I hear people talking about FAIR, my question is always like, how is this actually going to work? How are we going to realize the vision that everybody is selling? And so what I'm going to talk today about is some developments in trying to make FAIR a more realizable goal. And with that, I should introduce CoData a little bit. If we may not be familiar to people. CoData is the data arm of the International Science Council. And we're an independent organization, but basically, like the International Science Council, we're membership driven. So scientific unions, the academies of science, also organizations like the DDI Alliance. I think our newest member is CESDA, which is the European Social Science Data Archives. So we have kind of a mixed membership in CoData itself, but we exist to support the mission of the International Science Council. Now, I use the word mission advisedly because they're very into what we term mission science, which is science not for the sake of pure science, but to impact issues that are real in the world around us. And that's a bit what I'll be talking about more. You can see in our strategic plan that CoData operates at two levels, at a policy level, but also at more an implementation level. So we sort of pay attention to data issues, not only in terms of policy, but also we work a lot with implementation directly. We have someone in common. You may recognize this woman. She's our new president. I know you guys used to know her when she was at Harvard, but now she's our president, and she will be for the next 4 years. She just got elected in November. We were really happy to have Mercedes with us, and she brings to, we've had some very distinguished presidents in the past. They were always coming out of the research side, and she has an understanding of the computational aspects of science that I think is a real plus in the modern world. So I think she's, we're really happy to have her. I want to talk a little bit about the Decadal program, which is actually called Making Data Work for Cross-Domain Grand Challenges. This is maybe our biggest initiative in CoData. It's really focused on things like climate change, like disaster risk, smart cities, resilience, infectious disease, COVID. These are things happening in the real world that are inherently cross-domain in terms of the science needed to understand them. And ultimately, that means that we have to be able to use resources and data from different domains and be able to integrate those things to support better science. And that's a massive challenge. Like the ISC generally, we are very focused on collaborative issues in science, and specifically the data ones. I'm going to be talking a lot about the cross-domain interoperability framework today, which is sort of part of what's coming out of the Decadal program through a project called World Fair. You can read these slides later. There are lots of useful links, and you may recognize some of the acronyms, but the World Fair is basically a European project that was allowed, it was given an exception to include international members. Because when you start looking at issues of cross-domain FAIR, it's global. You can't really do it just for Europe alone. And so we were able to recruit a bunch of people from different countries. Here are the logos, and you may recognize some of these. Some of these are Dataverse users, I know for a fact, but not going to spend any time going through them. I want to talk about what World Fair is doing in terms of FAIR, however. And it's the only project I know that is really taking the approach, this kind of an approach. We have 11 different case studies in different domains, and we tried to recruit players in each of those domains that were concerned with what FAIR meant within their domains. And when you look up here, you have things like cultural heritage and nanotechnology sharing a slide. You have things like biodiversity and agricultural biodiversity through Embrapa down in Brazil, urban health, social science. There's a whole range of things, and across these different communities, what they think about FAIR, how they share their data and metadata, the standards they use, the platforms they use, are very different. In the middle of what we call the pedal diagram here, there's a thing called Work Package 2, which is where the cross-domain interoperability framework is coming from. What we're doing in that project is trying to identify the commonalities across domains so that we can get an understanding of what FAIR means across the board. This is not a comprehensive set of use cases, but it's a very broad-based one. And they have very different ideas about how to share data and the kinds of resources they want to share. And so establishing sort of an idea of how these domains could share with each other is a little complicated. And I want to talk about that because when I think about FAIR in any situation, but especially in a cross-domain situation, I'd like to break it down this way. It's a problem of scalability. We saw some impressive numbers this morning about how big the Dataverse instances are getting. But in truth, that's nothing. When you think about the amount of data that's out there, and I've seen projections that the amount of research data is growing exponentially, this is a huge problem for everybody. And yet here we are trying to document this stuff manually, and that's not going to work. And when you think about what's required to get metadata on data, what's required to use the data, and integrate data coming from different sources, we have to harness machines to be able to do that. Something like 80% of the budget in most big research projects is spent data wrangling. And a lot of that effort could be automated out of existence. But that requires having much better metadata. And by better, I mean more precise. You cannot actually get machines to do the things you want them to do easily unless you have very, very granular metadata that you can rely on. And what I'm talking about here is basically variable level metadata. And it may not be the kind of metadata you need to discover a data set in a repository, but when you're working with a data set, it's the kind of data you need to manipulate it programmatically and make things easier for the researchers and the users. It's really a shift in how we think about data and going away from sort of a file-based publication paradigm for data sets to one where the data is a granular resource that can be reused at a more atomic level. And that's a pretty fundamental shift. If we're going to make FAIR work, that's the kind of shift we're embarking on. And it also means that we need a lot better standardization. There are a lot of standards. In fact, there are too many standards. Even within domains, you have more than one competing standard in many cases. And when you go across domains, it's crazy. And yet, we need all these machines to speak the same language. This is a slide I like to use when I'm talking about the work on C. diff in Work Package 2. On the left, you see the situation we're currently in. And a lot of people in the FAIR world say, oh, we'll map this standard that we use against the standard of the thing that we want to use, and it's all good because we just map everything. But mapping across all the domains for all the functions you need to do with all the standards that are out there is an absolutely unmanageable burden. It's not going to work because there's no guarantee that any two domains will even map a target standard in the same way. This won't produce interoperability. And the idea behind C. diff is to reduce that burden by creating a common language, essentially, to identify some core functions around FAIR and core profiles in standards that are not domain-specific, so that there's sort of a lingua franca that domains can map to and from, and facilitate interoperability across domains in that fashion. And there's some things you don't need to map or can't map, but there are an awful lot of things you can. So CDIF is essentially a set of guidelines, not a new standard, not new technology, but a set of guidelines for using existing standards and technology to facilitate the implementation of a set of agreed business functions, if you will, in support of FAIR. So, and I'll show you that list in a minute. The idea is that you should have a set of progressive profiles of common standards that would be easy to implement for simple things and progressively more difficult. And the idea is to specify their implementation in a very, very direct way, a cookbook fashion, if you will, so that implementers can pick it up, implement it, and everyone can speak that sort of common tongue in addition to whatever they do within their domains. We've invited about 30 different experts from different standards bodies and FAIR initiatives to work on this, and we've been meeting every 2 weeks for the past 18 months. The project ends this coming June, so we're going to be coming up soon on the first release. The functional areas we're talking about are these, not a complete list, but an indicative one. Discovery, data access, controlled vocabularies of different kinds, ontologies, code lists, everything in between. Data integration, and provenance are sort of major focus areas here. You can see some of the standards here. Schema.org and DCAT are very big in terms of discovery and cataloging. ODRL may be an unfamiliar one, but it deals with digital rights. We're also looking at the data privacy vocabulary from W3C. People are probably familiar with SCOS and maybe OWL. DDI-CDI is the domain neutral flavor of DDI that's coming out in the near future. And that's useful for describing variable level metadata. There's something called triple SOM for mapping, Provo, again for provenance. Those are the kinds of standards that we're looking at. It doesn't matter how good a domain standard is. If it's domain specific, it can't be used for cross-domain purposes. And that's sort of how we've had to look at this. The technologies we're looking at are very much web technologies. JSON-LD turns out to be a really good thing because people who know JSON and JavaScript don't have to deal with RDF, which no one wants to learn except for him. And I don't mean to single you out, but that's a compliment, by the way. But it's great because JavaScript programmers do RDF without thinking about it. And that's a really powerful kind of bridging tool and a well-used technology. Not going to talk this slide. We have a bunch of different profiles in different areas with interdependencies. That's what CDIF really is. And if you want to get a better idea of what I'm talking about, follow that link and look at the draft of our simplest profile, which is for discovery. This is the kind of stuff that you think of as core metadata in Dataverse, okay? And we will be putting out a number of other drafts in fairly rapid succession in the next couple of months in different areas. Like I said, we're going to be done by the end of May. There will be another round of World Fair after this first round, and we are recruiting new sort of projects and organizations to participate in that. But what about Dataverse? Well, we have for a long time viewed Dataverse as an ideal platform for promoting fairness, and particularly cross-domain fair, using things like CDIF. Because you are implemented in a lot of different domains, it's an easy platform to use, and it serves that core function of allowing people to find data that they're going to take and use, right? So you're the distribution point, if you will, not only for data, but also for a lot of metadata, potentially. And so we're familiar with some of the work that's been done in places like Borealis now, old ex-scholars portal around DDI. And so we've seen that interest in the community. We think in terms of discovery, in terms of variable level metadata, in terms of access control, Dataverse would be an excellent sort of distribution point for creating what is essentially a network of fair infrastructures that could talk to each other. And I think Dataverse could be a platform for that. But I'm not a Dataverse expert, and I've seen things already today that made me realize there's probably a lot of things that could be done that could be explored further. One thing we have done, though, was to create a demonstrator tool. This was at a workshop at Schloss Dagstuhl this past fall, and we were playing with DDI-CDI and describing a multidimensional data set at a very fine-grained level. And the guy from the UN Statistics Division who works with the SDG indicators wanted a throwaway tool that he could mock up some examples with. So we built, in a couple of days, this little client-side JavaScript app that slurps into CSV and spits out a bunch of JSON-LD. And this turned out to be an amazing kind of tool. It's sort of like a wizard for CSV files. And in DDI, they're looking at productizing that now. And when there was a member from the Scholars Portal team at the workshop, and when she saw this, she said, oh, you should stick that in front of Dataverse, which we kind of thought was a good idea. Which is why I'm talking to you now. Here's a picture of the demonstrator, and if you follow that link, you can play with it. There's some sort of preloaded CSV files you can look at. But what it does basically is it mines all the metadata it's able to out of a CSV file, puts that into JSON LD, and then prompts you to do things like add labels and to indicate the roles being played by different columns in the table vis-a-vis the data structure. So for multidimensional data, what's a dimension, what's a measurement, what's an attribute? You can indicate whether these things are coded, it generates the SCOS, you go in and add the pref labels. So it minimizes the burden on a data manager for getting good granular markup of the data based on what it can mine out of a CSV and then prompting for the rest. The idea is that this should be an easy tool to teach someone. And what it generates is a few thousand lines of this Gook, right? So SCOS for all of your code lists, all of the DDI, CDI description of the data structure and the variables, links to the concepts, and so on. Which makes it a really easy way to get that information into a structured form. And you can save off the file or copy it and paste it. It also produces, if you look at the tabs, DDI Lifecycle and DDI Codebook. And all of those things are being produced at the same time, basically, with the same inputs from the user. So this is a really simple, nice little tool. And there is now a proposal. They're calling it Nectar Publisher. That rings some bells for the DDI people here, because Nestar is not a reality anymore. But the idea is that you should be able to consume basically any common spreadsheet format and have this kind of a wizard allow you maybe to reuse things that are already stored, like SCOS code lists or whatever. And the idea is that as a separate project, this could be integrated, because this would be a standalone client-side JavaScript. So a browser, it would operate in the browser, and you could have these extra files checked into Dataverse alongside the data that they were describing. There's some similar tools being built for things like SPSS that might also be useful. So this is an idea, and I think a pretty good one. I talked a bit to Victoria Lubitsch, I think is her, I don't know how to pronounce her last name, and she sent me some code examples of other apps that had been integrated with Dataverse. And I'm no expert in Dataverse, but it looked very doable to me, I have to say. So I don't think we're talking about a massive amount of development, but this could be very useful. This is my last slide. It's pretty clear in the FAIR world that we need more finer-grained, variable-level standard metadata. And maybe Dataverse could help us with that. We need simple tools that are easy to use for the kinds of people who do curate collections of data. And whether that's the person doing the check-in or someone doing a sort of value, a metadata add after the fact, I don't know, that's a workflow issue. But it seemed like Dataverse was a good platform for that. For cross-domain FAIR, we'd be looking at CDIF. For other domains, there would be other standards, like in social sciences, DDI, and there are obviously a lot of domain standards that you could consider. But I guess I'm kind of asking this community, would you be willing to work with CoData on this kind of a project, on similar kinds of projects? Because there's a lot going on in terms of FAIR implementation, and the era where people wave their hands and say, oh, it's got a PID, it's FAIR, are coming to a close. I think that's a good thing in terms of the maturity of the community and the promise of realizing the promise of FAIR, but we have to get serious about this. And in general, the FAIR projects are beginning to converge on this kind of an approach. And so I wanted to bring that to your attention and to sort of say, is there something that we can do together? Because CoData is happy to partner with organizations like GDCC. I mean, absolutely. So on that, I'm going to close.
Right, we'd like to invite our afternoon speakers to take a seat on the stage. We're going to have a Q&A. That would be Philip, Rory, Sess, Jonathan, Arafan. Oh, perfect. Okay, so we have the mic ready to go, and if you're also on the panel and you want to ask each other questions, you can. You can. Okay. We have one on that side.
Thank you. Hi, everyone. Thank you for your talks. So it sounds to me like across all of your presentations, a common feature is that, you know, we're all faced with this problem of all these different research software systems and environments. And I think a common element is this idea of metadata and PIDs adoption and this cross-domain discovery being really important. One thing that's a challenge for us, and I'm sure you all encountered this, is that to really get at like interoperability takes a lot of curation and sort of like domain experts to translate these things. And Arifan, you spoke about the need for tools to support this even for data sets in CSV format that just lack that ability to encapsulate that meaningful metadata in a format that can be shared widely and adopted and integrated. So can you talk a little bit about how you see this sort of cross-domain metadata interoperability happening in a sense that helps me understand, I guess, how this is all going to work, not from a technological perspective, but like how users will start to engage and do this kind of curation and cross-domain interoperability with you all, with the technologies. A little bit there, but yeah, if you want to start, that'd be great.
Fresh one. The example I like to point to is, well, there are two. One is the web. I think if you have a convincing case, a compelling case for people to share things and do things in a standard way, they'll do them. Metadata is expensive, but if it buys you something, then maybe it's worth the investment. And when you look at how quickly the entire world started using HTML the same way, that's an example that you can sort of think about. More specifically, there are large-scale networks that have developed fair approaches to specific functions that allow people to build massive knowledge graphs and navigate large amounts of data across organizations. And the one I like to point to the most is the Oceans Data Information System, which is discovery metadata. And they have 200 some odd organizations contributing all kinds of data about the oceans. And they have an amazing portal where you can search on it. It's completely distributed. And this is because of the sort of technology that supports knowledge graphs and so on. But what it comes down to is everybody agreeing to a core set of metadata done in the same way about the resources they have to offer. So I think part of this is just getting enough of those networks and infrastructures to do things in a common way so that they begin to connect. And the researchers will demand more, because I think people want to access each other's resources. And it reduces the cost of science massively. I think it's a huge return on investment. So I'm hoping the market dynamics will begin to drive this at a certain point. I do think that the cost of getting metadata is always going to be high, and maybe things like AI can help us with that. But I think there's a lot more work to be done in that regard, Amber. So.
It's just not working. Hi. Hello, is that better? Yeah. Anyway, yes, so I think a lot about interoperability. In fact, I thought about nothing but interoperability for the last 12 years. So I think in my view, metadata is critical, and maybe you'd say just sticking a PID on it is nothing, but actually it's a huge step forward. And I think most research tools are still at the level of sticking a PID on it, and that's an unbelievable achievement and should be applauded and needs to happen. The stuff that Arifan's talking about is next generation, which is also good. But I think an exclusive focus on metadata is wrong, because you get limited interoperability through metadata. So another kind of interoperability is interoperability between tools, which is what we started out concentrating on 12 years ago. And if you have different tools which actually can operate so seamlessly that they are in effect a single tool and the data can be passed between them, that's massively useful to the researchers. If as far as the researcher is concerned, the experience is as if you had one tool. So that is another kind of interoperability which I think is equally critical. I don't think there's any one route to interoperability. I think both of these routes are important. And also when you think about interoperability between tools, you've got vertical interoperability between different kinds of tools like RSpace and Dataverse. You've also got horizontal interoperability between repositories, for example, or data management plans, which is also important. So I think all of these different communities, both the kind of horizontal communities and the vertical communities, need to work together. And we also need to work together both with the PIDS providers, but also with the people who are actually telling us what the future is going to look like.
Yeah, if I can pick up on the metadata. So I think in many communities there are already standards. And if you take this to Dataverse, I think it's important that we agree on how to implement standards. So Case mentioned, for example, Darwin Core and others. So I think so once you have kind of figured out how we should do it in your data station, I think we should share it and we should kind of agree on how we could implement it in other Dataverse installations so that to ensure or improve interoperability. And also I think it's important to have some tools to capture metadata as early in the life cycle as possible, because otherwise it's very time consuming if you have to do this at depositing stage, because then you probably don't have all the information at hand anymore. So if you can improve integrations with metadata capturing tools that researchers could use, from the start, even if when they plan their research. So I think it would help to improve interoperability.
I work with researchers, and I'm going to make a very gross generalization. Researchers want one thing, and it's to publish. They want to do research, obviously, but they want to publish. When I use a phone, I don't care how the telephone works, and I don't want to know how a telephone works. A researcher wants to publish, they want to get the output out. So I think we need to make it easy for them. And the way I view this is to view data deposit as another publication, not an administrative requirement by funders or journals. And if you take the time to write an article, to publish it, you should take the time to publish a data set. So I know it's a focus on people and training and the tools, and you have the right tool to do this. And AI can speed this up. Because fundamentally, the researcher is the person that knows best the research, the domain, the way to describe things. As a curator, I don't have that expertise. I can tell you what you're doing wrong, but I can't tell you how to do it well. So they need to do this, and they need to have the right tool. But I think we need to view data sets as a legitimate research output, not a requirement to publish.
I'd like to follow up what the last two speakers said, because I think that upstream metadata capture is critical, and I think it has to be done invisibly to the extent possible. Researchers are terrible people. They don't want to document anything. They don't want to make your life easy or manage your data. They just want to publish, as if that's such a big deal, when the data is where the real value is. When I talk about a shift from a publication model to a data as a resource, I'm talking about the fact that the data has, in some cases, more value than the publications in absolute terms. And I think maybe eventually the world will wake up to that, but until that happens, we really do need to make the lazy researchers create this stuff without thinking about it. And I don't think it's necessarily that hard to do.
Just another thought on this. So I think the whole tenor of everything is researchers don't like metadata, they don't like PIDs, they don't like any of this stuff, they don't like data management plans, which is all that's true. But watch this space. I think IGSNs for physical samples and PIDs for instruments are game changers, because we're working with both of those, and these are things that researchers are desperate for. They want them. So it's not top down. It's not the researchers, someone telling the researchers, oh, you need to do this for this reason or that reason. Oh, we'll make it easier. Yes, we need to do all that stuff. But actually, this is an area where actually the demand is coming from the researchers because they see value they see this as adding value to their workflows. So to me, that's pretty interesting. And let's see how it plays out. But that could also have positive implications for the way in which researchers view other kinds of PIDs as well. So anyway, I think we should all watch this space. It's going to be a really interesting space to watch.
Another comment on that over here. Is this not on? Is it still close enough? Can you hear? Yes? No? Should I just yell? I was going to say, when we say researchers are terrible people who don't like metadata, I used to go around saying the opposite. We're all, horrible tool developers because we ask researchers to, after you've already done the project and after you already figured out the metadata and transferred it human to human and taught the grad students how to deal with the file system and the weird naming and so on, then we ask you to recreate all that as the metadata at the end with no chance that, we don't know who's going to use it after that. And so we coined the term active curation in an earlier project that was the same idea that if you put the data in and had a tool like you were showing that lets you put the metadata on, and that was enough to have the other tools in the research commons suddenly let you graph it and play with it while you're doing the research, it's already there when you're done, and you're not asking somebody for a burden, a big burden at the end. And so I think the ideas that we've heard throughout the day of, getting Dataverse earlier into the life cycle and tying it into research commons, those are going to be drivers to basically, once the metadata has value for the researcher while they're doing the work, for the stuff that they're paid to do, it's just going to be sitting there for us when we have to go publish it, and it'll be there for the next person who wants to reuse it. So I think we're developing that virtuous cycle to make it all go, right? And we're struggling to get from here to there, but I think that's what we need to do.
Is, we provide them with letters of support for their grant, but in the meanwhile, we've started sharing something like the Purdue data curation interview schedule and questions, because that allows them to see the things they have to plan for ahead of time, and we give it to them and say, answer some of these questions about the project that you're planning to do, because it's going to make it easier for you to deposit that data once you get this grant and you've actually started collecting the content. And use the Dataverse repository, the Harvard Dataverse repository, as a managing system for your project, not just a sharing system. Because then they're seeing everything ahead of time. And I mean, that's an effort that we have to put forth. I mean, I'm pretty happy with the grant administrators and the grants, the funders asking researchers to share their data, but you also have to give them the tools that they need to understand what they're going to be sharing ahead of time, absolutely.
So can I have a follow-up question? So you mean they should kind of create a data set when they start planning for their research project?
Well, they're outlining the questions they're looking at on this, for example, the curation tool, the Purdue curation interview guidelines, is they're asking them about how much data do you think you'll generate? What type of files do you think you'll generate? How long do you think you'll store for? What file sizes and file types are you considering? How many waves of data collection do you think you'll collect? And it has questions, I think there's some questions in there about metadata. But it's questions they need to consider, because when you're going into the sharing domain, now it's not just about your team, it's about everybody else that needs to understand your data, including the grant funders who want to see that your data are going to be usable. Does that?
Yeah, but that's the thing.
Data management plan.
Yeah,
basically.
that's the thing you would put in the data management
Well,
plan.
they would, but they also, and you're right, data management plan that people use, but, and so they're doing the now NIH data management plan, right? Now the questions are very specific, but we put together a whole guideline because some people didn't know how to, there wasn't a budget, they didn't know how to set up a budget, right? They didn't know that perhaps they should include a budget for data sharing. That's not, I don't think that was a standard or that people understood it or had the examples for that. Like our data management plan guiding documents actually gives you the, what's the word I'm looking for? It gives you the boilerplate language so that you understand the tools that you're using. I'm not going to expect a researcher to understand how to talk about access control in a technical way and put that into a DMP until they have some information from a repository.
I think summarizing this clearly indicates the big need for this whole fair enabling framework around your data, tools, knowledge organization systems that allow for verification of your data in an easy way and also trusted way. I mean, tools that people can rely on.
May I just comment? So I heard before that you were saying that data are the research output of the research, but in fact is the research input for the next research. And this is how science progress, like the same for the papers. So metadata is essential to make this data reusable and findable. I mean, this is the whole principle of FAIR. And I do agree that file-level metadata or variable-level metadata is the next thing we have to look into. And so we are happy to collaborate with CODATA because this is part of our Year 3 NIH grant. We already have DDI variable-level metadata in Dataverse, so we're already there. We can export in different formats metadata. Now a new framework called Croissant ML, which is specifically designed, is a schema.org version for machine learning or AI. And it's a variant of this. It's pushed by Google and other things, and Google and Kaggle, Hugging Face, so the new players around AI. And this is something we want to support. And it's just JSON LD. It's nothing else that is. So that's it. So we are open to collaboration.
Anybody have comments on that, or can we go to another question? No other questions? Any?
I have a question to Arafan. So in this cross-domain interoperability framework, so is the idea that you can put these kind of mappings in some place where repository metadata schemas in repositories could match to, or?
That's part of the thinking. I don't know if you're familiar with Fair Impact or the work in EOS probably. There's a group in Finland that's set up, I think it's a supercomputing center. They're building a schema registry and a registry of mappings. One of the things we're working on in CDIF with them is how do you document mappings so that you have, you can point to existing schema and say, okay, this is the schema we're mapping from and that's what we're mapping to, and here's a mapping you can reuse. What do people do with this today? They have an Excel spreadsheet buried on a thumb drive in an unlabeled box in their garage. No one ever sees or reuses any of that. And yet mappings are a key reusable fair resource in that way. So I do think that with CDIF, what we're looking at is reducing the number of mappings to a manageable number, and then using things like that kind of EOS infrastructure to better support the ones that are needed. People are lazy. If they can reuse something that's easy to reuse, then they'll do it. And that means we'll get an organic kind of interoperability because the mappings are the same, where they can be the same. If we let everybody redo everything every time, we won't get that. And that's the world we live in now. So.
Okay, so what we need to make sure in our database installation is that our metadata schemas are created in a way that they can be used for these, to connect to these mapping matrices or profiles.
I'd be very interested in talking to you guys some more about this. You mentioned Helmholtz, for instance. They're going to be involved in the next iteration of World Fair and looking at some of these things. I think we have some players in common, and it would be interesting to look at the standards that you're dealing with. Things like, we work a lot with GBIF, and the Darwin Core, well, they have a new model they're working on, and it's really cool, and they're going to get rid of the occurrences stuff that's in the archive and move away. And so those kind of shifts are things that we should probably talk about and look at how well that would map into a sort of CDIF framework. But we're looking at working with GBIF on that mapping specifically, for instance.
It's within Faircore for EOSC is the project called. We're actually working on these, what you just mentioned. Yeah.
We should compare notes.
We are aware of it, what's going on there. Yeah. It soon will be published. So.
Another place where we've run into this is UKRI. Not UKRI, but the Health RI in the Netherlands. So there's, yeah.
All right, mostly because of time, thank you very much. We are going to move on to our next couple of topics. Thank you. So our next couple of sessions, our next section is going to be large data support, and then we'll have another session on Globus and Dataverse. So for the large data support, we have Stefano Yaikas and Kaylin Boyd. And we've already met Stefano today several times, so I'm going to introduce Kaylin. Kaylin is the Dataverse Development Project Manager for the Dataverse Project at IQSS. This role collaborates with Dataverse team members and other stakeholders within the Dataverse community to manage, coordinate, and support program activities, including reporting, prioritization, and track deliverables. Kaylin came to us as manager of the Harvard Library Research Data Services Group. And she's also finishing up her doctoral dissertation at Simmons University, investigating the theoretical modeling of research data and how data curators identify, define, and repair research data in data repositories. So welcome, Kaylin. Stefano, are you after? Okay.
Yeah, he comes next. Okay. Thanks so very much, Sonia. Okay, so we're going to talk today about Dataverse and large data and computing support, meeting the challenge at Harvard Dataverse Repository. I'm going to try to start my time. You know us. Basically, you're all aware, you've all experienced this, that researchers become more data and compute intensive. And here at Harvard Dataverse, we've been experiencing the same thing, increased number of requests for large data support, but also increased interest in computing on our data collections. So how do we meet this challenge? Well, it's kind of twofold. The first part is I'm going to talk about, which is how to develop sustainable large data support services, emphasis on sustainable. And then Stefano is going to tell us more about how we're going to be bringing data close to compute. So a little bit of backstory here. In Harvard Dataverse, we've, over the last 5 years, received many tickets revolving around large data support. 51 tickets in the last 18 months. These all involve current planned collections. They're from hospitals, Harvard and non-Harvard researchers, research groups, government departments, et cetera. Question is always like, how large is large? Well, we're talking anywhere from 1 terabyte to over 450 terabytes of storage. And so when you take a look at all of these different use cases that we've been analyzing over this time, a couple of things stand out. So for one thing, folks are very interested in immediate and individual file access. So they're not just looking to park something in a dark archive and never see it again. They want to use it actively. The next thing is, again, how big is big, is they're looking for support for millions of files. So some of these files may be small, but there are a whole lot of them. So how do we handle that? Also, how do we handle collection growth and versioning? So these are some of the challenges that pop up out of our use cases. In addition, there's interest in restricted content, whether that's sensitive data or other kinds of restrictions. We've also been asked about indefinite retention, which is interesting. And then, of course, there's the ever popular, everybody wants a budget-friendly option. How can we do this in the cheapest way possible? So how do we do that? Okay. Did I miss one? No, I didn't. Okay, so we have some large data support infrastructure that's available to us at Harvard. You've seen some of these icons pop up before in earlier talks. We have obviously Amazon Web Services support through our Hewitt University IT. We're partners with the New England Research Cloud, the Mass Green High Performance Computing Center, and also Northeast Storage Exchange. So we've got all these different kinds of hardware, storage, et cetera, resources. Research computing resources. We also, so what do we do with this? So we have these different options available to us. We think about how do we make use of these options and keeping in mind the different use cases that I brought up earlier, right? We've got AWS S3, which you're all familiar with, Glacier, which you're familiar with, and there's obviously pluses and minuses to all of these, right? Allow dynamic access, widely used, et cetera, but can be very expensive. There may be file transfer access costs, et cetera. Data cold storage, it may be cheaper, less expensive, but there's still costs associated with it. But there may be some monitoring interfaces and administration interfaces that are useful. Similarly for our NESI, which is the Northeast Storage Exchange, we also have some options there, NESI disk and NESI tape. Along with the disk, we have, unfortunately, some file size limitations. We get lots of benefits, but a little limitations. File size, file count limitations, and not as good, say, administrative monitoring and overhead. With tape, we have everything that comes with tape, the benefits, low cost, big storage. However, there's some delayed interactivity, and there may be some limitations on the file size and so forth. We also have some software infrastructure that's come to us recently with respect to upload and download from Dataverse. That includes Globus transfer, direct to S3, to file tape, et cetera. So you kind of combine these two, storage resources, our technical infrastructure with some software infrastructure, and we start thinking about, well, what does it actually take to build and deliver sustainable large data services? So what are the kind of considerations we discovered? They're really in three categories. The first is technical, the second is curation, and the third is in the boring administrative category, but it's very important. So let's take them one by one. In terms of the technical challenges, they're everything you pretty much would expect, right? Storage costs, transfer costs, the interest in people doing interactivity between users, individual files and applications. There's also some constraints on data arrangement, whether it's file size limitations, file counts, and then there's backups, right? So we have to think about that. In terms of curation, when we did our analysis on the various use cases, some curation challenges and considerations popped out. For one thing, there's interest in custom metadata. There's need for metadata extraction out of existing documentation that goes along with these files. There are some constraints regarding file arrangement. In some of our use cases, folks are not able to repackage files in a more friendly way to the storage infrastructures. They're constrained to how the data must appear to the user. And then, of course, data access. And we're getting some increasing special requests for like visualization, data exploration and analysis and support combined with this. So then we come to administration, right? This is the sustainability. How do we address all these diverse use cases without using what I consider artisanal solutions, right? We don't want one at a time, custom, we need to be able to scale this. So we need to be able to kind of slot different use cases into tracks so that we can easily spin them up and make them available. We also, as you saw, we're working with multiple organizations, so we have quite a bit of cross-org workflow coordination that we have to do, a lot of technical support tickets, user communications, et cetera. Then, of course, revenue sharing agreements. How do we do this? How do we do account management? And then again, how do we monitor usage and assessment across all these different options, right? In order to actually get payments. So towards this sustainable services, what we did is we developed some service categories, service offerings, and then of course our pilot. We're doing a pilot. So here are our categories. When we did our analysis, what we wanted to do was focus on the access component because this appeared to be the thing that was important across all use cases. Did folks need immediate access to files? Could they tolerate in their use case delayed access, like an hour, a couple of days, whatever it is? Did they just need cold storage? It needed to go away and they just need an archive somewhere. The ever popular custom, inevitably someone will fall outside of the standard options. We'll have to assemble a custom solution. And then of course, backup. How will we provide backups? We could provide it on tape, we could provide it on Amazon Web Services, Glacier, et cetera. So there's a number of options that we could have. Then we have our large data service offerings. When we took a look at all these use cases and so forth and did some interviews, it became clear that there are a couple of key offerings. First is this pre-service support, which Sonia alluded to in her last question, which is, folks are asking for letters of support from us. They are asking for quotations, for grant purposes, and so forth. So what do we do to help folks before they actually need our services? Then there's this large data administration, right? It's overhead. We have to do it. We have to track and monitor this. We have to get things across workflows. How do we do that? So we have to think about that as being part of the service in order for it to be sustainable. We can't just assume that all of our different service partners are just going to absorb those costs or absorb that work. We want to make the work visible, right? There's obviously curation and technical support. We're thinking of technical support in the form of, say, DevOps. Folks may need assistance, uploading, downloading, et cetera, moving data around. There's obviously our large data storage and access services, and then finally, large data and computing support, which Stefano will talk about. So in terms of our pilot, our goal here was to develop and document these cross-org workflows, to establish the administrative infrastructure in order to support and sustain these services, to create service delivery estimates, so we'll be able to tell customers, users who come to us, exactly how long it's going to take for them in order to get onboarded, to get their services and so forth, and then, of course, revising our service models, the things that I showed here. At the moment, we've got 2 confirmed collections, one that's 8 terabytes, one that's 2, but it's a very open-ended collection that's getting updates like every quarter, so it's going to be growing, so it'll test that capability. They're all Harvard affiliates, which of course simplifies our billing and administration hurdles. We're working with Nessie Tape, so that simplifies things a little bit, but one collection requires computing support. And so with that, I'm going to turn it over to Stefano, who's going to tell us a little bit more about what we're doing to bring data close to compute at Harvard Dataverse Repository and then integrate it into this service.
Thank you, Kaylin. So now I'm expanding on what I presented today, this morning, about integration. So the whole idea of this is not just having access to large data and run computing on the data, because this is already possible in Dataverse. You can reference any data outside Dataverse storage. You download the data, you do the, oh, thank you. I was freezing, yeah. I need to stay here. Okay, anyway, so I'm talking about this part of the vision, so the integration between the computing and the storage, all through Dataverse. Okay, so I don't want to spoil the next talk by Jim, but I took some of his slides just to introduce the point. So we, as you know, we already have several previewers and AI tools that we will show in the next days, but so far they all work mostly for small data. Even the AI previewer doesn't allow you to manage large data. Thanks to the way Dataverse has been conceived, Dataverse has different ways of accessing storage. So S3, file store, remote storage, and now, thanks to Jim's work, the Globus store is fully implemented, which give us the opportunity to go towards large data support. Let me skip this one. Okay, so what we implemented last week, outside of the Harvard Dataverse repository, so we create very quickly another Dataverse installation through containerization, and we went to the, say, MOC Alliance infrastructure, which is the combination of Nessie, which is this space, and computing environment, which is called NERC. NE is for New England, stands for New England. So there are different ways that this type of data can be accessed, this type of data or data support can be accessed. So either through Swift or POSIX connection, or if you come from outside, you can access, thanks to the Harvard Data Commons project, through the Globus endpoints. So this is how it works. So for this, we created, we ingested essentially just 2 files in this simple Dataverse installation. one is based on tape and the other one is based on NESI disk. Okay, so that's the infrastructure we have built. It's all local to the same physical infrastructure. So the data, there is no egress cost, for example, whenever you access data or remove data within this infrastructure, which for large data, it's a huge part of the cost. So for example, for Harvard Dataverse, the egress cost is the largest part of the budget that we spend every year, just for letting people looking at our data, so which is crazy. So on NESI and say this infrastructure, we don't pay any egress costs. So anyway, so the idea is that here you have the user connects to this Dockerized instance of Harvard Dataverse and can upload data to disk or tape according to the necessity. And then there is also a Jupyter notebook, say Jupyter Hub instance, which is pinned according to the needs of the user. And this is the very delicate part, which requires centralized authentication services, which are still working on with Dataverse. Because whenever you run computing, you have to sustain the cost of computing. So not everyone at the moment can run computing to Harvard Dataverse because we need to find a way to bill for the compute time. But it will come. Anyway, so that's the whole idea. So we start with real data. So this is one of the collections. So we didn't want to play with the toy data. So we took data from this project, which is called a GEOS CAM dataset. This is one of the datasets which is uploaded very frequently. And it's all about say chemistry data around the world, which serves different other services like NASA and so forth to generate their models. So it's a reference database, so it's quite important for this community. The point is that they develop a software, they have an archive to say distribute metadata about the software, but they don't have anything about the data itself. So they just have an FTP server, which sometimes goes down, and things like that. So they thought that Dataverse was the right solution for this. Okay. So I will go fast here because this is what Jim will be presenting. So essentially now there is this opportunity through the Globus app developed in development by Borealis that you can upload data through Globus. So once you click there, you get access to your Globus endpoint. Dataverse takes care about all the authentication steps and all the I'd say the access right that you have to the different files on the Globus endpoint and on the Dataverse side. And then through the Globus API, it makes possible to transfer data. Okay, and you see the Globus side and the Dataverse side, so how they look into data. So I'm going fast because I guess you will be presenting this. Okay. So once the data, once this process is ongoing, of course, there is also, it's not real time because we are uploading terabytes of data, so there might be a delay in when the data are ready, and so we exploit essentially notification to make, to notify the user that the data are now completely transferred and available for usage. So once you have the data there, on the standard Dataverse interface, you see a new icon, and this icon is about, it informs you about the fact that this data now lives on the NESI tape storage. Meaning that to access this data, you need the Globus app to browse this data. Okay. So similarly for the NESI disk, so if you specify NESI disk, you have a similar thing. But now, as I show you today, whenever Dataverse understands that you are on NESI disk and it sees a Python notebook. It now works only for Python notebooks, but we will extend to other frameworks like R. Now there is this new sub-menu in the Access Data menu, which appears, which is Compute on Data. So once you click there, now at that point, the Jupyter notebook is run. So this virtual machine is run for you. And the nice thing is that all the files are mapped as local files into the Jupyter Notebook. So there will be no, say, internet transfer of this data. So you don't need to copy this data locally into the Jupyter Notebook, say, directory, and then load them into the data. So here is the S3 endpoints for the Nessie disk, where this data live. This is the notebook that those users provided to show some computation on this data. And what happens in the background is that all the S3 endpoints are mapped to the local names that the Python notebook is actually using to call. So it means that you can execute this script on Dataverse, through Dataverse, like you were executing it locally, without the need of remapping all of this, because this is done by this tool. And then you have some computation happening, plots, whatever you want to do. This is an interactive notebook, so you can play as much as you want. That's why you have to pay for this computation when you expose this to the general public. So this is my last slide. So the roadmap for this, of course, is to moving this to production. So not just the support for large data, but also the computation part. Then giving the ability to configure the requirements for your, say, computational workflow, because, of course, we prepare a standard one, but you might want to run an LLM, so an AI model, and then you need GPU or you need VRAM, whatever. Now it's only accessible to NERC PI, so which are Harvard or Boston University or Northeastern University PIs who have an account there, and for which you can bill the compute time. And then for this version, we are using the present implementation of the containerization, which we can explain you about in this workshop, in working group meeting, which is called OpenStack. So we use the standard Dockerized version, but we are going to move it to OpenShift, thanks to this working group, which is essentially a way to run it on Kubernetes so that you don't need to scale the web application manually. All the work is done by the Kubernetes for you. Anyway, so as said, Harvard Database is essentially cost-free and is open to everyone, not just for Harvard academics. So we need to make it sustainable in the long term. And the other thing is that MOC, in our case, has the administrative support that we can exploit, especially for external, say, client or external users, which are not NERC PIs, but they want to distribute their data. So there are companies who want to give out their data for good. They are in the order of terabytes, and they don't want to manage this data, they just want to put them out. But then if you want to compute on this data, someone has to pay. And so they have the way to help us with this model. That's it.
We have one more talk and then we'll have a Q&A session. So we're welcoming Dr. James Meyer. Victoria is not here. And Amber? Coming up or no? Oh, okay, Amber, all right. Well, I'm going to introduce both of you regardless. So I know software designer, developer, Jim. And then we have Amber, I always mispronounce your last name, don't kill me, Leahy. Okay, either one. Okay. She's the service director for Borealis, the Canadian Dataverse Repository, and the Data and GIS Librarian at Scholars Portal in Ontario Council of University Libraries. At Scholars Portal and Borealis, Amber supports national infrastructure development for libraries and researchers, community training, stakeholder, and governance relations, participates on various Digital Research Alliance RDM groups, and is an inaugural member of the Data Site Canada Steering Committee. All right.
So are these still on? Sounds loud enough, okay. So I've got good news, bad news. According to the schedule, I've got 3 minutes to talk, but But the good news is you've already seen most of the slides, right? So, so let's see which one. All right, so basically, you've heard the word Globus all day long today, and I want to tell you basically, kind of go through a little bit slower introduction of, what are we talking about with big data? What is Globus actually for? Where did it come from? And then get into what has been done over, 4 or 5 years now to get Dataverse and Globus to work together and give you a sense of what's in the 6.1, 6.2 that's coming out right now and kind of what you can do that you couldn't do when we've talked about this in previous Dataverse meetings. So, and did I miss the slide that was people? There we go. All right, it's just slow to come up there, so I got to watch over here. So Victoria was mentioned. She's the developer at Borealis who's put this together in Amber stuff, and I'll give you a timeline before, but they basically were folks who kicked it off, and they've been partners in everything that has been done since. So, all right. So large data, essentially, I was looking up to try and figure out who did the quote of, quantity causes its own, right? Quantity is its own quality, right? Basically, things become qualitatively different when you have lots of quantity. And it's the same thing with data, that as it gets big enough, and it was either Stalin or it was John Connolly from the US, but they were talking about military and stuff. But anyway, when data gets big, right, the first thing that happens is the data gets big, it becomes costly. But you start to get to the point where when data gets big, you can't just send it in a single stream across the internet. You have to break it into pieces because you want to do it in parts. If you're talking about lots of files, it's easy for you to monitor and see if 3 files got across. Your grad student or whoever can do it with 300, but what happens when it's 30,000 or 100,000 files and it's happening once a week? Those kinds of situations, you basically have to automate everything, and you have to deal with those kinds of both quantity of files and quantity of bytes. It essentially becomes qualitatively different. So one of the takeaways I want to say here is, if you're thinking about Globus is a nice tool and the integration is helpful, but really you're talking about the kind of things that Kaylin was just talking about that they're going through at Harvard. You need policies and procedures around this because it really is a different kind of paradigm. All right, so Globus, I could say lots of things about, but I'm going to basically try and focus on the bold words here that Globus is a transfer mechanism, right? Just like HTTP moves things around. There are 3 things that Globus does that you sort of don't get out of the everyday web. One is it's efficient. It will parallelize things, so instead of trying to send one stream, which even if you've got a massive network, a single HTTP stream for technical reasons won't use all of it. So if you want to get all of the bandwidth used, you have to send multiple streams at once. Globus does that. Globus, when you're talking about this scale of data, it's also something where you can't just have multiple streams from one computer. When we talk about transferring in Globus, you're talking about a cluster of machines on one end that's talking to lots of disks, all of those machines sending part of the data at once. So it's not even single machine to single machine, it's cluster to cluster kind of transfers. So Globus does that efficiently. It also does it robustly. Again, Globus is used both in high performance computing and high throughput things, but it's things like telescopes. So lots of those are down in Chile, up in the desert and the mountains. If the network goes down for 2 days and you started a transfer, you want it to basically continue when the network comes back. So Globus has a service out there that's basically monitoring, and any transfer, once it's started, Globus will make sure it works. If it fails, Globus will restart it. If the network goes down, Globus will retry when the network comes back up. So much better chance that all of your data is going to get over the way you want it. The last thing there is third party. And again, sort of obvious when you think about it. You're sitting using Globus and Dataverse on your laptop down here in the corner. Your data is in one cluster and you want to move it to another cluster. If you were just using HTTP, you'd have to download it to your machine and upload it back, because there's no way in HTTP to say, move it from there to there, and I'm a third person sitting out here and directing the transfer, but bytes aren't going to my machine at all. So Globus also is a third-party transfer mechanism. So those three things make it basically, when you get to big enough data, this is really the only game in town because it does all that stuff and that's what you need. The last thing I'll point out down there, there is a Globus Connect Personal, and that essentially is one where you can launch a Globus endpoint on your laptop. So if you do have data that you need to move from your laptop into the Globus endpoint, you can do that as well. Obviously, your laptop is never going to be the same kind of scale and speed as the other stuff, but you do have a way to kind of deal with what you would normally do with HTTP. All right, Globus uses, I didn't want to say much on this slide other than just pointing out again that this is something that for our community, Globus is probably a new thing, but anybody who's coming to you with big data because they're doing it at a supercomputer center or with a telescope or whatever, they know Globus, right? They use it every day to transfer already. So I'm going to show you interfaces in here, basically from the technology, how you do it, and how this looks for transfer, they're going to be familiar with. So that's a good thing for us that we have to learn about it as Dataverse and administrators, but basically your users should be ahead of you on this. All right, and so again, I will skip through this mostly, just basically pointing out again, you've heard all day long that people are having, users come to them with big data issues and with data to compute issues. So for all of these things, this is really something when you get to this scale where our other data transfer and data storage solutions don't work, this is really the way to go. And we're talking about all of those things basically of how do we do this medium to large data transfers? How do we deal with things that when data gets big enough, you really don't want to move it at all. It was created on a supercomputer, and the only thing in the world that can analyze it is that supercomputer, so why do you want to move it? So any of these things are the kinds of use cases that we're looking at when we do this. All right, so in terms of the timeline of this, again, this was stuff that Borealis started back 2018 to 2020. I forget what Dataverse it was, 4. something, but they basically came up with a working proof of concept. That's the same thing I'll show you now, basically some changes inside Dataverse, and then a separate app that's kind of like our external tools that dealt with the transfer. And between those two things, you could do the uploads to Globus. There were some limitations of it, both that it was only to and from an S3 store, which I'll say a little bit more about. But basically, by 2021 or so, the Harvard Data Commons was starting. There was support there to try and bring this into Dataverse itself. Other people in the community were getting interested. So I kind of came in on phase 2, basically trying to take what they had done in 4.x and pipe it into, update it into version 5. Whatever we got the initial Globus stuff out in. And so again, there were updates at that time, both to the core code in Dataverse and the app. The last phase here that I think I was teasing about last year is that we wanted to do some new things where we're pointing out that for technical reasons, when you're talking about those big cluster stores for Dataverse and the largest data, you don't want to put S3 as an intermediate protocol in the middle. It slows things down, it's extra burden, and so being able to go directly to file, you've heard that tape is essentially the cheapest storage we have. But once it goes to tape, it may take you an hour to get back. So that means you can't just click the download button in Dataverse and get it anymore, and so we have to deal with the delay. We also wanted to deal with that remote storage linking where you don't even move it. We had, in previous Dataverses, we talked about this remote store idea where if something's out at HTTP, blah, whatever, you can say, put that in Dataverse so I have a data file, but leave the file at that original HTTP website. Now we want to do the same thing with Globus. So those are the kinds of things that were put into this round of stuff. You've seen this graph as well. And again, just if you're new to Dataverse, Dataverse itself sitting on a file store, you're probably good up into the gigabytes, and then people are going to start complaining because things get slow. They're hard to work with. S3 stores are inherently more scalable, and with this direct upload download that we've had for a few years now, you can basically do somewhat of a third-party transfer. You're saying from my desktop, tell Dataverse I'm doing a transfer, but send it straight to the bucket. Don't make it go to Dataverse and then have Dataverse have to make a copy and send it over there. Just send it straight back and forth to the bucket. So that sort of pushed it out, so we're getting up into the hundreds of gigabytes people have used that for. Beyond that, again, everything I've said so far, you really need another mechanism, so that's where we started getting the Globus transfer. And then, again, because S3 has limitations in the Globus world in terms of how well it scales, you really want to go to this file and tape to go beyond that. And then again, finally, you get so big that you don't want to move it. You may want to do that just for the quantity, or it may be something where you don't want to move it for security and sensitivity reasons. So that's why I sort of put the remote as scaling all the way back down to 0. You may have very small data, but you want to have it in a remote store, whether it's a remote HTTP or whether it's a remote Globus, just because you're going to manage the security on that end. All right, so the original S3 stuff was essentially you could connect to one Globus endpoint. And so if you wanted to use Globus, you had one choice. Along the way in Dataverse, we started going from you can store data in one place to you can actually have some on file, some in S3, use different, 2 or 3 buckets if you want. We now have the same mechanism in here that Globus is just another store mechanism, so you can set up multiple Globus endpoints if you want to. And just like you can assign any given collection or data set in Dataverse to use a given S3 or file store, you can now set those individual collections up to use a given Globus store. The 3 kinds of things in here, I don't know why I did it, but the S3, the old one, is in the middle. And essentially there are a few differences to them. The Globus endpoints, file and tape is kind of the standard Globus endpoint. The S3 connector, you actually have to pay additional money, or whoever's managing Globus for you has to pay money for, so that's a downside for that. The remote store is essentially you're using somebody else's, right? You're gonna make some trust agreement with somebody, but it's all on their end, and it's probably a file or tape endpoint. In terms of Dataverse being access control, the first 2, we're still trying to use Dataverse access control mechanisms. So if you've got a restricted file, or if it's a draft data set, only people who are supposed to be able to get to the draft data set are going to be able to see the stuff that you've got in there. With the remote store, right, it's essentially available directly from their store, and you're going to reference it in Dataverse so you can add metadata, put it in a data set, give it a DOI, but we're not really in charge of the access control. Whatever the original access point is, they're doing access control on it. So that's a difference with the last one. Whether things are actually transferred, the first 2 were actually transferring it from somewhere out in the world to something that you're administering as the Dataverse instance. The last one, we're just referencing, so wherever it is, right, it stays on their end. They're dealing with management of it. And the last thing that's different is, as I was mentioning with the tape store, because there's a delay, you may have to wait for it, but also we have not yet built into Dataverse the ability to actually talk Globus and get the bytes for Dataverse itself. Right, we're allowing you to transfer stuff from your endpoint to a Globus store, but all the things that we do, like ingest, being able to have a previewer show the bytes, being able to do checksum validation, that HTTP download, those are usually not supported by Globus endpoints, and so they're basically not available if you're doing the managed store or the remote store. The nice thing about the S3 one in the middle is it's essentially a Globus endpoint and an S3 store. So you can transfer in with Globus, but Dataverse can talk S3 and get the bytes, and we can hand those bytes to the previewer so you can see them in previews and so on. That sounds like a pretty big limitation, but you don't want to put a petabyte in a previewer anyway, right? So a lot of the things that you might do, you don't even do checksums on things that are petabytes because you're just having to run all the data through. So a lot of this stuff, it's not such a bad thing that you can't do it, but it is a difference. The last one, I'll just note that I'm talking about Globus as though there's no HTTP mechanism. There is actually an option that the Globus endpoint can turn on to let you have HTTP download. We haven't dealt with that in Dataverse yet. It's an optional thing, and again, it's so inefficient that most places I don't think they turn that on, but there's a potential that could be fixed. All right, so the upload process here, I'm going to kind of go through what the user would see. I've got some words and then I've got some slide pictures. And then when I'm done talking, I'm just going to run, there's like a 4-minute video that Victoria put together. And I don't want to narrate it, but I'll let it run while we're getting set up for the discussion. Basically, just like we have now, if you go to the upload button in Dataverse, if you've got it set up correctly and extensively, you may see in there already that you can drag and drop files in. You might be able to upload from Dropbox. You might be able to invoke the DB uploader to go upload a whole folder of files. One more button that can appear is upload to Globus. So it just appears like one more option in the upload panel to people. Once you click that, like our external tools mechanism, it pops up the separate app that Borealis has built. That app you've seen the pictures of, and I'll describe in more detail, but basically that's where you decide which files you're going to move in and find where they are out in the world, select them, and move them into Dataverse. Once you say submit in that app, you essentially have told Globus to start the transfer. And again, with these things being big, transferring terabytes may be several hours. So what happens at that point is the app says, time to shut me down. Dataverse, here's the transfer ID for the task that's going on. You monitor Globus over time to see when the files are actually in place, and when they're done, tell us that they're in the data set. So basically, Dataverse is sitting there waiting for the transfer to actually get done. Oh, and I can't see the end either any more than you can. I can see it over here. So yeah, basically that's how things work, and I'll show you the user interface. The last point is just pointing out that the app, just like all of our previewers, is doing nothing more than using the Dataverse API. So if you want to use that API directly or use it with another tool, you can do that. All right, so here's just the upload part of Dataverse. You can see there's our normal drag and drop, and there's the upload with Globus button. You click that. The first thing that you'll see as the app comes up is, Globus is another app. You've got another login over there. And so basically, you've logged into Dataverse to be in Dataverse and setting things up. When you go to the app, you log in with Globus so that you can work with Globus to do the transfer. It does the normal stuff of asking, look, you're working with this app. Do you want to let it work on your behalf? And you say yes. Then the tool pops up. And again, you've seen this. I'll do a couple highlights. But this is essentially, because it's doing extra things with Dataverse, it's a separate app. But really, it looks a lot like the normal Globus transfer tool that everybody uses every day to do normal transfers. Up at the top, there are my personal endpoints, ones I've used before, and let me go search out in the world for any Globus endpoint. Same buttons that are in the normal Globus thing. Once you do that, you're going to have the endpoint that you have is going to have files and directories in it. So you're going to be able to wade through those and click on either directories or files. When you click on them or drag them, they'll show up in the space on the other side, so that those are the ones that are sort of staged for Dataverse, again, just like the normal Globus app. And then you hit the submit button down at the bottom. And when I took this, the little icon at the bottom says, all right, transfer is started. So at that point, you basically can close up the app. If you refresh your data set, you'll see that there's a Globus transfer in process. So we've locked the data set so we don't get multiple of these things going on at once or other things changing the data set. It will lock for minutes to hours, depending on how long the transfer takes. When the transfer is done, the files will be in the data set. So just like everything else we normally do. Underneath the hood, you saw this slide, but to narrate it a little bit more, this works essentially like our direct upload API for S3. You essentially tell Dataverse at the beginning, look, I would like to transfer some files. I've got 5 files that I want to transfer. Tell me what I need to know to do that. Dataverse at this point goes in and says, okay, you're trying to go to this data set. I will give that particular Globus user access to write to that data set for one transfer. Once it does that, you go in and you talk to the Globus API directly, and you go make the transfer start, and you get that task ID I said, and then you basically come back to Dataverse and say, remember me, I was uploading 5 files. Here's the task ID, the transfer's in progress. Start monitoring it. And here's all the file metadata. So if you've used our API at all, you know that you can set the title and the description and the MIME type and the size and so on. It's the same JSON. You just send it in just like you would normally for any other transfer. And Dataverse basically just holds onto it until a transfer is done. And if the transfer succeeds, Dataverse does the same thing it does before and it creates the files and things. So I'm not talking much today about transfer out, the download side. Essentially, it's the same thing in reverse. The app is involved as well. On our download menu, you basically, instead of having a download, you have a transfer via Globus button. You click that, it pops up the app. You can see the files in Dataverse, and you can go find an endpoint out in the world, and you tell Globus to transfer it out. So in the API level, you request to transfer the files. You start to transfer on your own out there. And then again, because we're doing access control from Dataverse, when you tell us to begin with, Dataverse is granting you read access to the files in that data set for a small amount of time. You tell us at the end, here's the task ID for the transfer, and once the transfer is over, Dataverse is going to take your permissions away. So we're basically managing that you only have that window of time to do things. Diagrammatically, again, you've seen this, and the only things I want to say on here really is, again, you've got the Dataverse server and the transfer app are talking to each other. It's really the app that is starting the transfer out in the world. Dataverse is the one actually managing access controls at this point. And Dataverse is monitoring the transfer in Globus to know when it's over and did it succeed or not, so we can know whether to add the files or not. So it's lots of arrows on here. And again, just to hark back to, right, this is more difficult, more complex than S3, so you don't want to do it if you don't have to, but when you do need to, this is what it looks like underneath the hood, and this is what you'll be dealing with. The referencing remote endpoints, it's essentially like our HTTP remote referencing. The files remain in the original place. With HTTP, we store the HTTP URL in the Dataverse database so you know where to go. In this case, we store the endpoint path and name of the file, right? So that's essentially what we have to tell the app and tell Globus, go to this endpoint, go to that path, and get this file and do something with it. So that's all it does. The one thing that again, Stefano pointed out is that we can give it a label so that in the UI, you'll see a little label that will tell you this is actually stored remotely, so you have some sense that it's not the same as other files in it, and you sort of brand the remote store that's helping you out by storing this data set. They've got their little brand name up there. All right, so there are a couple limitations in here. The first one, basically, we're trying to do access control, like I said. There's one limitation to that Globus only does access control by directory, by seeing everything in a directory, you either have access or not. And right now, Dataverse puts all the files for one data set in the same directory. So that means when you ask to get access to one file, we're granting you access to all of them. So really, you can't do quite as fine-grained with restricting as unrestricting as we normally do. We hide that well. We can make it so that when you are granted access to one file and you try to download it, we're only going to show you that file name as something that's available to transfer. If you knew what you were doing, you could go under the hood and go get access to the other file as well. So it's fairly good, but not completely secure that you can't have differential restrictions or embargoes within a single data set. They're all going to work the same. The other thing I already mentioned is just the ingest previews, all those things that work because Dataverse can get access to the bytes. Those only work with the managed S3 store. And the last thing here is that with both the S3 direct upload and with the Globus stuff, Dataverse has mechanisms to limit the size of files you can upload, and we now have the quotas that you heard about where there's an overall quota for how big a storage you can have within a collection or within a data set. Those work here, but they sort of work after the fact. Basically, you can put the file up, and once the file is in place and we see how big it is, we can say you shouldn't have done that. So the file will have gotten transferred, your file will not show up in Dataverse, but you essentially, somebody needs to go clean up at that point. Again, with the app, we're sending over, here are the limits, so the app is going to not let you do things if they're over the limits, but if you use the API underneath, somebody could do that. So again, it's big data. You need to monitor what people are doing in the place, in the stores that you're managing. All right. The last one, again, I've basically said this, it's just one more time. This is complex. There's lots of stuff going on. You really need policies and procedures around it. Other things we do normally in S3 are easier, so if you don't need it, don't do it. But when you do need it, this is the right approach, and it's now going to be in place in Dataverse. There is a lot of documentation out there, so this is mostly for reference, but we've got a whole big data section. We've got a section on how to configure the Globus stores in the configuration install part. We've got a section on the Globus Transfer API with examples how to do it. The Globus Dataverse app has its own repository with install and setup instructions going on there. We have a separate doc right now that essentially, if you're going to run this in production, you're probably working with somebody who is setting up their own endpoints. If you're going to do testing, the Globus documentation isn't great on how to set up an endpoint and do it yourself. So we've got a doc of basically what we've gone through to try and get this set up. So that's, if you want to do testing, you might want to see that doc as well. And then again, we've got community Slack and chats and so on that you can go take a look at and ask for help in. All right, with that, I'm going to fire off the video if it will go here and stop talking. So let me do the thanks first. And again, what you'll see in the video is basically what I talked through. We're going to go into a data set, open the Globus app, select some files, and download it. She goes back and sees the Globus lock, and then she goes back in the app and shows some of its features and some of the options that you can do, and then goes back at the end to see the files. So that's what happens. So with that, thank you. And again, thanks. This was a nice partnership with Borealis sort of leading the way, with Harvard getting involved, and we basically come up with a nice thing for the community. So thanks again. Yeah, so is that... Hopefully it's running. I can't tell if it is or not. It may look really static, so I don't know if it's going to run. Hopefully online we can get one that runs. I don't see any buttons here to fire this off. But fortunately, all the stills that we've done are essentially the same thing, so I don't think you've missed a lot.
I can share it too. Okay, so we're going to have a Q&A session. Amber, do you want to join? Please. I noticed they keep turning mine down. Okay, I'll hold it down.
So first of all, thank you for the presentations and congratulations. This is absolutely, awesome, and I think it's transformative, and this is the future. So I think I'm just like blown away. So thank you very much, and congratulations, and well done. So my question is, as you kept saying, Jim, this is only probably for certain kinds of circumstances, and I know it's interesting, Amber, you're obviously envisioning this being useful to the Canadian Dataverse community, and I understand the kind of, at the high level, what the use cases are, but could you drill down a little bit and maybe think about some of the actual Dataverse communities, not the data, who's going to actually be driving this? Let's say Dataverse NO or someone else. What would incentivize them, or what would make them think, because it's a fair amount of work to do this, to support their researchers in these kind of workflows? And maybe, Amber, you could talk to that, because you've obviously thought about it, because you're actually representing users as well as helping to develop it.
This one is still working. Take that.
Is that working? Yeah, okay. Yeah, I mean, I think Kaylin also spoke about the need for establishing services around this so we can have a coordinated approach. But overall, the flexibility of this integration allows for so many different use cases. In Canada, all of the high-performance computing centers are using Globus. And, they have their own national repository as well. I think interfacing with these different repositories using the remote storage linking features, including Globus remote storage linking, is really powerful. But I also think there has been a need, and we've been constantly requested to support large data, large volumes directly in Dataverse, because while the high-performance computing centers are amazing and they support so many computational use cases for analysis and collection and beyond, they don't do archiving. They have an explicit mandate, for the life cycle of a project. There isn't currently preservation happening widely across high-performance computing centers. So these managed endpoints are managed for 2 to 4 years on average. I think the flexibility to support different storage backends using Globus and Dataverse is really where we should be going. Because the current upload to Dataverse using S3 and whatever storage you have under that, that's great, but for the terabytes of data, I don't think that will work for all the reasons that were outlined earlier. So that's just sort of a little bit of my perspective on things and where we might be going with Borealis. But I would really love to hear from you, Kaylin, about Harvard and what Harvard's planning to do. So,
is this one? Okay, this one is working. Okay, good. So I can say a couple of things. I'm sure Stefano, feel free to chime in, correct me if I'm wrong here. But we had quite a number of use cases, and like I kind of alluded to, they kind of go all over the map. There's lots of different communities in terms of scientific communities, biological data, genomic data, et cetera. I mean, it kind of spans the gamut, so it's not one single type. And then again, the use cases were so distinctly different, I think was also a really big challenge. And that was why, one of the things that kind of keeps me up at night is thinking about, okay, well, how do we make this sustainable? How do we not have to mobilize the entire development organization, et cetera, in order to acquire one set of data, right? One data set each single time. And since these requests are accelerating and folks are wanting to write us or a partnership into their grant applications, it's more coming. So I think that that's something that was motivating us and certainly motivating me for thinking of how to kind of make these less artisanal, less, one at a time, and more thinking about kind of a workflow approach of how are we able to kind of look at use cases very quickly and kind of say, okay, you fit into this category, this category. How can we kind of easily slot you into these different options? I don't know if that quite captured what you're looking for, but that's really it, is just thinking we keep getting these requests. They kind of appear to be all over the map, but certainly there's some rationale under there and categorization that we can do in order to make the services scalable.
Oh.
If I may add, there is another use case that we are considering. So we have already 70 terabytes in Dataverse. Not all of this data are accessed every day. So by analyzing the way the data are accessed, even for new collections which might appear, usually researchers think, okay, my data is the most important data in the world, but then only one people access this data. So by monitoring this data, we can decide ourselves, without the user knowing this, to move something on tape. And so for this, the Globus endpoint is very useful. And we save cost, and we can scale even more the accessibility.
Okay, because we actually have questions also coming in from our chat. So it's the same question, actually. So does Upload with Globus allow you to automate metadata creation, such as file description, for a large number of files, or would you have to use the Globus Transfer API for it?
So we basically have the simple capabilities there, both on the S3 direct upload and with Globus. We're sending the app may help us make this different, but basically when you use the API level or tools like DV Uploader, which does the S3 direct upload, it's not smart enough to do metadata beyond when it looks at the file, it gets the file name and the MIME type in it, so it can do that. But if you want to add a description or tags or other things, you have to make a separate API call to send that. That's not really, that's a limitation of that tool rather than the API, and so that may be something where if we wanted to add into the Globus app over time, the ability to like add a tag to the 100 files that I'm going to upload, that could be part of the one call to Dataverse. So it's really a feature that we should request in the GUI where we want it, or in the DV uploader where we want it, rather than the API can already handle that. And again, your alternative, if you have that metadata separately, you can always make a separate call or use that second tool, even with any tool that will let you, for 100 files that exist in Dataverse, go add a tag to them. You don't have to couple that with the transfer, so you could make that a separate tool, a separate API call to do that as well.
All right, thanks for the nice presentations, and I'm very excited to learn about like Globus and also compute data. Especially compute data is something that we're very interested in, and we deal with a lot of simulation data, and certainly like post-processing of terabytes of simulation data is something that is kind of an issue for us. We have solved this by just having a Jupyter Hub at our HPC center. But the thing is like, yeah, we would like to integrate this also with Dataverse, and this looks very promising. So my question is, how applicable is this to already existing systems? Do we need to just establish Globus and a couple of other things, and we can just work the way we did it as now, or do we need to set up something completely new?
Okay, what we developed for the proof of concept is based on our own infrastructure, but it's actually generalizable to any infrastructure. So you don't need Globus. I mean, if you have data already there in a large bucket, and you have a Jupyter notebook who can access this data locally, then you can just spin the container, pass the reference to the files, and that's it. So we're trying to generalize this concept before going into production, so that everyone in the Dataverse community can use in their own infrastructure. So if you have special use cases, please talk to us. We are happy to make it even more flexible. We already had the binder connector. Finn is here. He's the guy. So we actually generalize or specialize this binder connector to this case, but it can be generalized even more.
Cool. Thanks for the information. Yeah, getting good news at home. That's nice.
All right. I think we're going to end here because we have. And it would be great for our community to hang around and hear briefly from our sponsors for the meeting this week. Jesus, actually, if you can do that, I can give you this. Thank you, everyone.
So, yeah. Thank you. We have here with us Miguel Tiempos from Hewlett Packard Enterprise, who would like to give us some words, so please welcome him.
Hello, hello. Well, thank you very much. I'll be as brief as I can. There's a lot of good stuff going on at this event. I want to thank CIMIT, Harvard, for allowing us to assist in the event. We have been working for quite a while now with CIMIT with all their technical needs, high performance computing, all their requirements for USDA platforms where CIMIT does research in containers, in all sorts of different formats. And we're glad to be here and to support the scientific community. We just want you to know that HPE, Hewlett Packard Enterprise, is always close to you, whether you're in Canada, Africa, Europe, Mexico, all over Latin America. We are here to support you in everything that you need. Everything that was presented just now with S3 buckets, that's our common day-to-day products that we move, that we connect with storage, connect with high-performance computing. We work with everything from the #1 supercomputer in the world, Frontier, which does nuclear research in the US, to USDA research in plant and genomics, and we sync information all over the world with different platforms, from S3 buckets, our Emerald Data Fabric, through Wi-Fi, through all sorts of communication networks, and we help researchers do more quicker. That's one of our main themes, to perform any type of scientific workload better, have the fastest speed in our high-speed fabrics, to storage, to compute nodes, anywhere from 100 gigabits, 200, all the way up to 400 gigabits today. With our own networks, with our partners' networks from Mellanox, InfiniBand, and Slingshot, we have been acquiring, I would say, some people in HPE would say, too many companies. We acquire companies left and right to support your workloads, anywhere from integrating data, all sorts of dispersed data. With Pachyderm, we use our HPE machine learning development environment platform to work with machine learning, artificial intelligence, training our models the best way possible, integrating data with Pachyderm so you can do more trainings on your models quicker, and that way we can get results better. We have been working with people in genomics that do the what-if scenario and reach better results quicker. So all this is at your fingertips if you ever need anything concerning data fabrics, S3 buckets, high-performance computing, high-speed networking for high bandwidth and very low latency. Talk to us. We're always willing to help. And along with working with CIMIT and organizations like yours, we also have different programs to help you get funding. So if funding, I know everybody needs funding, we can also help you there. If you need that, come talk to us. You can talk to the staff at CIMIT. Mr. Richard here at CIMIT can help us get you what you need and collaborate. We have a network that we're establishing first in Latin America for some close to 16 different organizations for research, for nonprofit organizations that we're going to be sharing HPC equipment, network equipment that's going to be here in CIMIT, starting here. We also have another program in Colombia where we'll have HPC clusters, and we'll share machine time with a platform that we have at HPE called GreenLake, which allows you to pay as you go in the consumption of high-performance equipment. So anything that you might need, including funds, we can help you. So let us know, and thank you for this time, for this opportunity. Hopefully the Wi-Fi worked good. I know why you were getting disconnected yesterday, but it was a different brand. It starts with a C and it ends with an O. But our nodes are out here in the facilities. If you need anything else, just let us know. And a great honor to be here with Harvard, Simit, and every one of you that are doing research, not just for you, for your lab, but for humanity. Thank you so much.
Thank you. Now over to Sonia.
We are done here for the day, but don't forget the opening reception is tonight in the, what is that place called again? I know, same place where you had lunch. Rincon Mexicano. It'll be fun. So if you see other people that left the meeting early, tell them 7 o'clock. We'll see you there. Thank you for a great day.